It's upstairs. I think the entire, like, second part of the conference is upstairs. All 3 floors.
Thank you. spaziale, con addirittura fu qualche volta da esperienza perché mi spiegavano sul studio, ora facevo la casa di mio Dio io che si poi per dire la casa ok.
región. Are you leaving the room?
Yes.
Okay, so also no pictures.
Ah, okay.
Oh,
I was trying to put sticky thing with yours, cables, and I managed to do that. I tried to do that. Yeah, I don't do that, yeah.
are we connected online? Yes.
Yes.
Okay. Because I have a link and I can download.
Yeah, feel free to stop the sharing.
Okay. Thank you very much.
When does your session start?
What?
When does it start, the session?
Matthias thought, in 10 minutes.
Ah, 10 minutes, okay.
I was wanted to do it in iOS and macOS, but there it is.
Yeah,
Ah,
I know, it's, my application.
No, I don't find it. Have you ever tried one of in Turkey they have two kinds of
Okay.
one is a QWERTY keyboard, and the other is made only for Turkish language, which is why they will know the fastest typing thing. It's not made for mechanical reasons, but for frequency, etc. And this keyboard is an iron. Which one? This one. Because they also have the iron up. But it looks exactly like our iron because it is capital. We don't have the dot. So every time you write the index, you need to do. Good.
Hilarious.
You deserve a love, it's like, it's amazing.
Um, what is this?
I'm gonna check you out.
I thought they I thought they put videos. But they were nice. We did some. So while we are on
Did you manage to copy?
yeah.
Beauty?
Okay, and so this we open it in sort of PowerPoint. And we
Is it possible to extend the screen, for example, to have like a reader notes on one side?
I don't know what version of
Sorry.
PowerPoint this one is, but it looks like a very old one. I don't know even how to maximize the script, to be honest. You see it? Not. Maybe they change this one by one. So maybe view. Okay, so what if we try to open it with the browser? No. That's it.
Yeah, but then it's okay. Oh, no, it's good.
It's not moving, and because so, Okay, wonderful. No.
Can you see if you can also share it using Zoom?
But for now, I cannot even really present it. Because there is not something to open a PDF. And if I open it with, do you know how to present it? Like how to have presentation mode? With PowerPoint. Probably good enough.
Then you can put it full screen.
So,
And you can decide which one you use, and we see if it works for everybody. You should see the yellow thing. So you should be, if you're happy with this, I don't think it looks too shabby.
well, good enough. Okay, let's put the other ones.
Okay, Mikhail first.
Yeah, and second presentation, so
Put it on. So we know already that everything is working. Make sure that you speak sort of in the direction of this one, which goes into the streaming.
Yeah.
And you can also use this one for the room instead. So I'm going to ask you to, if possible, stay in this vicinity.
okay, so it
Either
can be
sit-
like,
Yes. Let me see if this works.
Yes, it does. It's even too bad.
yeah, maybe I can leave it like a little bit,
You can try.
or I can sing.
Yes. Well, you can sing in Dutch.
No, I can sing some Greek.
Let's leave it for later. Like, in stories,
I'm Mexican.
¿de dónde?
Del norte.
De norte. Okay. Está bien.
¿Tú eres de
videojuego. No, está bien.
¿De dónde?
De Italia.
Italia. ¿De qué parte de Italia?
Del norte,
Del norte.
como, casi como Matías, que vive en Torino. No, vivía.
Ah, ok. It's... Oh, me encanta esa área de Torino. Lombardy. Okay, here. What's up? Lombardy.
I'm from Lombardy, like this.
Yeah. No?
So do you have
Di certo in Est sono in Lombardia, ma essere bellissimo.
So it's in Chrome.
Yeah.
Voy a meterme con costing.
Yeah.
Es en una Canva, en Canva.
Matías, you present twice today.
No, she will be present.
She present. So you do
One
one
to the
together.
first one,
and
one the rest two. And
Okay,
then,
and Zampeta the other.
yeah.
This is pronounced correctly. Zampeta.
Yeah, it's perfect. Thanks.
Tomorrow we present also the paper for Daniel because it's remote. Okay.
So we have 1, 2, Nele third, and Zampeta.
Hey there.
Nele is from the University of Antwerp. She does most
We
of
met in Digger
Yeah.
Okay, yeah.
a month ago.
Philosophy and fiction and sometimes games.
Imagination.
Imagination.
Sometimes a bit of narratology.
Fun stuff.
I think so.
E tu sei un amico di Riccardo, mi diceva che ti conosce bene.
sì.
Lavoro spesso con lui.
Anche se io sono tanto ormai.
Sì.
Qualche anno che non lavoro più io, ma sì, con un tot di colleghi anche se meno del gioco lavoro. C'è Marco Giuliano, Vincenzo Leone Cassano.
No.
Se sentite il nome.
Ahora me cambió a teclado de griego.
Do you want to change in
To
the language
English,
or
yes.
something?
So, cuando es mi presentación voy a ver, se puede extender, ¿no?
Vamos a intentarlo, pero no hay PowerPoint. Entonces, no sé si pueden.
Sí, no,
si
no.
es posible.
No uso PowerPoint.
¿No tienes tus notas de ningún otro lado?
En la otro laptop.
¿Qué
Puedo
tal? ¿Por
tenerlo,
qué no?
sí.
Exactamente, ¿por
Al
qué
lado.
no sacas tu computadora y la pones ahí?
Ya. Bueno, tendría que presionar aquí. Pero puedo hacerlo.
Es un poco lúdico también.
Rústico. A ver.
Menos problemas. También wireless.
Tu español es perfecto. Sí.
Sí, habla súper bien.
Ay, es que viví un buen en México.
Ah, ¿viste? En Ciudad de México.
Por eso tengo este acento de campesino, ¿no?
And you, where are you from?
Greece.
Greece.
I'm from here.
Elinaki.
Yeah, very nice.
I love Greece.
And then we're done because soon we need to start.
Yeah.
And we need to also install neighbors.
And also another one. Your
Yeah, I can go.
No, I think they already installed one.
No, I haven't.
Oh.
It's here.
Sorry that I'm taking my time, but I'm not gonna take my time. Just connect to Canva and it's gonna awesome.
Technically, like you only have to put the PowerPoint on.
Yeah, yeah.
Just a bit worried because it's a different version of PowerPoint. So only
Yeah, I also have a lot of animations that I have no idea how to work.
Yeah.
Mind them.
So
it would be interesting presentation.
I just need this one, and let's see how it works. The presenter. So, okay. Okay, so Costas, this is yours, right? Mm, ¿Qué pasa si no voy a cambiar ahorita, pero ok, sí lo puedo extender. Ya lo extiendo y ya se puede poner una pantalla acá y cuando.
Okay, but make sure that you take it away when the other people are coming after, okay?
Yeah, no.
Okay, so now, Neda, you just look this up.
There is no coffee break after.
There's no coffee.
We'll just push the session after us further into the
Yeah,
future.
that's
I'm gonna try to keep you on time. Guys, you know it's gonna be about 10 minutes, right? And 5 questions a day. I'm gonna be very, very strict because everybody needs to chance. So hopefully I will either have to get news or have to read.
Yeah. I don't know, like usually 1 minute after that happens.
I'm gonna let you know. Are you happy today?
Yes,
How is
fonts are not good, but
Thank you for this. Let's see if Zoom is working correctly. All right. Greetings, everybody. We have 3 minutes of delay, with which we allowed all the speakers to install their presentations and to copy them on this computer from which we stream, and also hello to everybody who's present at the stream. Let me see, we have 2 participants in at the moment. Okay. It's going to be a bit of a problem because I can only let people in using this computer. So it is possible that during your presentation you will see a little thing appearing saying, "Do I admit this person in the thing?" Please click that or ignore it. This is one of the late-breaking paper sessions. That means that each speaker will have about 10 minutes to talk about their topic, and then 5 minutes in which I will ask the public and the people online to interact with questions and answers. So without further ado, the first speaker is Mattia Thibault from Tampere University, and he's going to talk about something that has to do with his project with forests and forest representations. Mr. Klaus?
Okay, thank you very much. So let's try again to. Okay, good enough. Hello everybody, my name is Mattia Thibault. I am assistant professor in Tampere University in Finland. I'm presenting to you a short paper written with Daniele Fernandez Galeote, with Joseph Macy, and with Henrietta Dilla. This paper is part of a larger project called Unite, Human Forest Machine Interplay, which is an academic Finland project that basically deals with all forms of interaction between forest, machines and humans, from silviculture and exploitation of forest to sort of ecological maintenance. And there is one of the working packages, working package 4, that has to do with gainful forest interaction for meaningful experiences and practices. So we've been working with several colleagues, also into looking how social cultural representations of forests appear in game and in playful practices. So in the last couple of weeks, I've been presenting a lot of short papers about this. A couple of them were last week in Thessaloniki in the World Congress of Semiotics.
Let me make sure that you are
Yes.
sharing the screen. Because
Ah,
I
oui.
don't know if we...
Thank you very much. And there goes 1 minute of the few time I have. So, in the two presentations that were presented at the ELS, one was dedicated to the representation of forest spaces as playful spaces in discourses of tourism in Finland, and the other one entitled "One Moment in the Blueberries" was about foraging in Finland and the importance of playfulness. Here in the PG, we also presented two papers dedicated to the representation of forests in video games. And this first one is dedicated to, let's say, a theoretical model to look at this. So we decided to look at several layers of representation of forests in video games. But I think I missed this slide, yes. So first of all, forests are important. Trust me, I don't have the time to explain you why, but I'm pretty sure that you have some ideas. And they're important not only economically or ecologically, but also culturally. We have plenty of representations of forests, from Robin Hood to whatever you like, the forest in Minecraft, and different cultures look at forests and represent them in very different ways. So eco-criticism is a field of literary theory that analyzes the textual portrayal of forests, or nature in general, but in our case we're focusing on forests. So here we propose a critical framework to look at the representation of forests in video game, and in particular across 4 different layers: a cultural layer, a discursive layer, a representational layer, and a living layer. So let's start from the cultural layer. So we agree with Lewis Close that the opposition between nature and culture is two separate things and an ideological one. It's not true. It's just one possible way of looking at nature and culture. And in this level of analysis, therefore, we try to look how a specific culture, or the culture represented in the game, positions nature and culture in relationship with each other, and in particular, again, forests. So we do this using local semisphere, which is a concept that comes from semiotics of culture that I don't have the time to go through, but I think it's quite intuitive when we are looking at it. So basically, we can position forests in different places around the semisphere. It can be outside, so it is a space of chaos, or a savage space, where other inhabit barbarians, monsters, animals, and so on and so forth. It can be on the border of our semisphere, so the border of our culture, but it becomes a place of translation between the outside, so chaos, and the inside, therefore the cosmos. It can be even a peripheral space, so part of the cosmos, but still a sort of minoritarian part, may be inhabited by some marginalized groups. It can be hippies, it can be hunters, but again, groups that are not, let's say, the most big important groups in the culture. Or in some cases, the forest can be at the very center of the semisphere. So it is one of the main aspects of our culture. We can see this in reality, for example, it's a tribal culture, but in fantasy, for example, with elves. Then, in the discursive level, we can, of course, have all kinds of discourses about forests. We look, in particular, at the valorization, so how discourses create value around forests. And to do so, we use the square version of it. So, according to Freud, there are 4 main kinds of valorizations, and all of them can be used to give value to forests. So, if we look at practical valorizations, that are based on utilitarian values, we can see forests as resources for economy, military, or educational resources, for example. If we look at critical values, then forests are ecological resources. They create oxygen, they regulate the climate, etc. If you look at existential values, then we have utopian valorization. So the forest becomes a place to escape, a place of freedom, a place to go into the wild and get out of the brick. And then finally, we have ludic valorization, in which forests become playgrounds, recreational spaces, also luxury spaces. We have then a representational level, of course, forests in digital games have been represented in all sorts of ways, and there are many, many different aspects. We try to align several, some based on the argument work, so basically dimension, so 2D or 3D, order of perception, visual outlook, audiovisual motives, audiovisual style, soundscape, and sensomotorism, so how you interact with sensory activity. But we also added some levels related to ecocritical representation. So the completeness or accuracy of the representation of the forest, the distinctiveness of is this just a generic forest, or maybe understand something more about it, the temporal features and the spatial features of the forest. And then finally, the last level is the ludic level. That, of course, is what put the forest into motion, it what involves the forest in relationship and interrelationship with the players. We used, again, the argument to look at some of the ludic levels, namely components, environment, rules, and game mechanics, the information, interface, players, and contexts. And also, in this case, we looked at some ecocritical levels. So the perspective, so who is the player, is it a human, is it a natural being, player-forest interaction, and also some markers of environmental sensibility. So, for example, cross-species interaction, environmental variability, and dark knowledge. So I went through the model very, very fast, because I would also like in the next 3 minutes that we have to, well, show you a short analysis, and in particular the analysis of Jack Lumber. Jack Lumber is a rather small and simple game, we chose it exactly for that, but it's also one that proposes sort of unusual representation of the forest. As you can see from the main image, the idea seems like to be about cutting down forests, but interestingly enough, this is a revenge story. Jack Lumber hates trees because a tree, a smiling pine tree, killed his wife. And so the idea is that you hate trees and you want to cut them. But at the same time, you like animals and you want to save them. So at the end of every level, you save a different animal from the forest and you bring it into your own log cabin. The game is a slicing game, so it's rather simple and straightforward game mechanics in which you have blocks jumping out and you have to cut them according to several rules. So what we can see with the analysis, very fast. So the control level, we can see that the space is designed as the border of the city sphere. So it connects the two worlds. This allows some translation, especially the animals that are taken from the forest and brought into the log cabin, and conflict, so this conflict between the lumberjack and the trees, especially the smiling pine tree that attempts to kill it. At the descriptive level, and this is maybe one of the most interesting finds, there is a conflict between two types of valorization. One is a practical valorization, because the logs that are cut can be used as an in-game resource, and an utopic valorization, the idea that trees need to be destroyed as part of the story of revenge. At the representational level, the aesthetic of the game focused on three goals: supporting gameplay, conveying a cartoonish, satirical impression, and relating to the theme of the game. And from an ecocritical perspective, we can say that there is little or no effort to make the first representation accurate or complete. At the ludic level, the game is very simple and straightforward, and again, from an ecocritical perspective, we can see that it's clearly anthropocentric. There is not any depth of the interaction between the player and the forest beyond cutting trees and saving animals. So to conclude this very, very quick analysis, what we have seen is that there are two main tensions, or there is one big tension in the game, which on one hand is a slicing game that offers a shallow and utilitarian portrayal of forests, but on the other hand, we can see that the game diffuses these critical programmatic aspects by adding numerous elements of satire, fantasy, tongue-in-cheek humor, and cartoonish aesthetics. So our model, of course, is still in its infancy, it still has some limitations, and of course we need to test it on other kind of games and maybe more complex games, but we believe that it was at least able to uncover some important dimensions in this specific game. And this is 10 minutes, and I thank you very much.
I feel a bit sorry with late-breaking papers because it was starting to get interesting, and then we need to cut it down. Obviously, like this is kind of the nature of those kind of presentations. It's ongoing work, so it's quick and dirty. If we have questions from the audience, if we don't, I have. Oh yeah, okay, we can.
You need microphone?
I'll just maybe.
You can scream and you can repeat it.
But maybe for the audience online?
I'm just trying to figure out which one is quicker. Oh, well, it's not. Thank you, this is fascinating. I've never heard of this game. I'm wondering if there's, in your analysis of it, did you detect like a sort of self-awareness element or like a meta element, or basically the way it seems without having played it, right? There's a lot of eco-friendly discourses, there's a lot of greenwashing going on, everybody's green these days, and now we're going to make a game about cutting down trees sort of unapologetically. Is that something that comes into play? Does it reflect in some way on like consumers' culture? Is that a consideration in your analysis?
Yes, thank you very much. And of course, I didn't have all the time to explain many of the things of the game, but one of the interesting features is that one of the animals that you collect, which is the very first animal that you collect, continues to make this sort of meta remarks about the game. So for example, after a while, the normal animals to collect in the forest end, and you start to collect giraffes, and whatnot, and the beaver makes fun of it, saying that this doesn't make any sense anymore. So there is an element of meta, which again is used, or still to diffuse the idea that the game core mechanic is something that we consider somehow, maybe even a bit, I would say, unironically bad. And again, this is a very small game, it doesn't have thousands of players, it's still available on Steam. But the point was exactly to test it in something small and to see how even in a very small and simple game you can find some interesting aspects to analyze.
Thank you. So I would like the second speaker to come on stage, and in the meantime, while he sets up, I can still talk to Mattia, for example. So I was wondering, for example, in the game that you presented, there doesn't seem to be forest really. So it is more like a narrative context rather than something that the player encounters, right? And the player encounters animals and dogs, but never quite the forest. So when I got to meta review your paper, I was like, well, I mean, this game about forest presents no forest, right? It's like a mystical context. So I would like you maybe to comment about it before Mikhail loads his presentation. Are you good?
Okay. In towards the forest, you can sort of see them as a cutscene. When you get to the forest, there are thorns, and basically you make them explode, and then just cut the logs when they're coming down. But this is very interesting because it shows exactly how the forest is completely taken an unholistic way and separated in discrete elements from the very beginning, which is against anything that is eco-critical.
Which makes sense with the framework you decide for the analysis. Thank you very much, Mattia. And we have the second speaker. I hope you can introduce yourself, and you are good to go.
Share screen. I think I'm sharing
It's already sharing, so you can go.
Perfect.
Look at what everybody sees is here.
And
Turn around.
okay, yeah,
It's great.
Okay. So
Wait.
hello everyone. Welcome to our presentation. The Telmaker database extension. Oh, sorry. I hear differently. Welcome to our presentation. The Telmaker database initiative co-created stories. My name is Michael Bueno, and I will be presenting on behalf of myself and my co-author, Rafael Vidal, who is also here. We are members of the Computer Graphics and Visualization Research Group at Dell University of Technology. I'm very happy to be here because it's my first conference after 3 years of PhD in person. So thank you. So we can acknowledge that there are several datasets of stories and texts that are useful for many research fields. For example, for the research field of story reasoning and story generation, we have this a very popular dataset of short stories, which consists of a sequence of sentences, and each sentence aligned to a photo caption, and is often used for the visual storytelling task. We also have other datasets called rock stories. It's also a collection of short stories composed of 5 sentences. And also, well, for other tasks, for example, word sentence ambiguation, which is a task of trying to predict the meaning of words within a text, we have datasets such as Sencor and OMSTI. They are often used for this task, which have a lot of text with sense annotated words. In this case, they use syntax from WordNet to define the good meaning of words. So we have a lot of datasets for different story generation, story reasoning, and natural language processing tasks. But despite the usefulness of these datasets, they have suffered from the burden of being manually altered and annotated. So it takes time and can be a tedious task. And as a consequence, this usually limits their size and their potential to grow in the future. So as an alternative way of putting together a dataset of annotated stories and text, we propose the Mixed Initiative Cooperation process of Telmaker, where Telmaker is an online multiplayer game that facilitates the co-creation of stories to play, and where stories are fully annotated and stored in a database. So in this presentation, I will give a very quick overview about the game, but keep in mind that there's another presentation coming tomorrow that it will have more specific details about the game. So in the beginning of the game, players go through the prompt phase, where a player is randomly selected to add 2 custom characters and a set allocation for the story. For example, a pirate and a parrot and their names, and also a location, in this case an island. And what this does in the game is that it allows players to interactively form creative associations among these elements so they can unfold the story. Later on, when players decide to change the location of the story, the process is repeated by another player who introduces 2 new characters and set a new location for the story. So after this phase of the game, players collect tokens, like if they were simply words, and they use these tokens to plan a sentence for that story, where each player does this individually. So they collect tokens, and after that, they use those tokens to compose a sentence which involves also the available characters, the location, and other pre-included tokens. When all players have completed their sentences, they submit it for a voting round in which the sentence with most votes is chosen to be part of the story. It becomes the next sentence of the story. And after this phase, they repeat the turns several times until players decide to end the story. When a majority of players decide to end the story, all players must propose a title for the story, and a final voting round decides which title becomes the title of that story. And then for our purpose, finally what we do is we keep those stories because we argue that they are important from a cultural and a research perspective. Stories in Telmaker have a simple representation, which consists of a title and a sequence of plot points. From the perspective of players, they construct sentences, but for our internal representation, we call them plot points. I don't know what is supposed. A plot point describes an action undertaken by a character or characters in a particular location of the story. A plot point is composed of a sequence of slots, each holding a token. A slot is a space that describes the role that the token plays in the plot point. This could be a character, it could be an action, a verb, and a location, and also a free slot that is reserved for anything else that is not these elements. So we have the actor, the character, action, free slot, and the location. Internally, all plot points have stored the location of that particular plot point because it was set by the prompts of the prompt phase. And now we go a little bit to explain to you what a token is. From the perspective of players, this is a word, but to avoid any ambiguity in their meaning, tokens are defined with a worded syntax, which facilitates players to use the proper meaning of a token to correspond to what they are trying to convey in the sentences, because we explicitly show an illustration, a word, and a description that we retrieve from words. And tokens also have a pile indication, which is a category or part of speech obtained from words. And as I mentioned before, tokens are the building blocks of plot points. So, at the end of the game session, the story is stored in our database. And for the database, we use our relational schema that consists of 4 core tables: stories, plot points, slots, and tokens. Each row in the storage tables contains the name, which is the title of the story, an identifier of the story. We provide additional information such as the number of plot points and tokens within the story. In the plot points table, we associate a plot point with a story and a token of the plot point of that and a token of the location of that plot point. And also the plot point holds an index of its position in the sequence of plot points of the story, as well as the turn of the game when it was created. Only plot points that won the turn have an index, and the turn can be used to extract other competing plot points that were created at the same time but did not win the game. And we have also other elements like the number of votes and also textual representation of that plot. The slots is what holds the token, so we store them in the slots table, and the tokens store the coordinates identifier of that particular sense of the token. We implemented the database in PostgreSQL, and the stories can be retrieved by SQL commands. For example, we can retrieve the plot points of a given story like this. And this is how a query of plot points look like. In blue, I showed the plot points that were the winners of the game. So they are the ones that are part of the story. And on red ones are the ones who were not included in the story, but nevertheless, they are important for the story, for the data. A few potential applications very quickly. The storage engine generation, it needs a lot of data, so we think that our stories can be useful for story generators, like say anything, creative help. We tell more about it in the paper. Also, it can be the data of the maker can be used together with this and rock stories. So I'm going to skip this because I don't have that much time. It can also be used, the data in Telmaker database can be used for word send disambiguation, because we can, all the stories in Telmaker, all the tokens have a sense, so, and they have a particular context together, which form a sentence, and all the sentences form a story, and everything is sense annotated. So it also can be used for the task of word sense disambiguation. And for example, our sense disambiguation is trying to predict, for example, the meaning of the word cell, in this case, for how it is used in different contexts.
We hear your conclusion.
Yeah. And I'm going to the conclusion. This can be found in the paper if you want more information. And conclusion, in this presentation, we describe the story representation and the relational database schema of the collection of stories from Telmaker. And also we discuss some potential applications that would benefit from this collection. I didn't go into all of them, but in the paper you can find them. And well, I think this is more like an invitation, but the stories that we gather with Telmaker are going to be freely available. So you're welcome to use them. And right now, the game, you can also play the game if you want to contribute new stories to the database through telmaker.ai. So feel free. It's now available for Android and PC. So thank you. And
do we have questions for Miguel? Matthias, very quickly.
Either you repeat it or, okay, he's going to use it. You can already.
Thank you very much for the presentation. I think it's a bit of an ambitious project because stories are more than just a selection of things. So have you thought of how to create a story arch, like some sort of meta structure in which you have several acts or something, like how to link these different things, or do you hope that this is something that only comes sort of bottom up from the
That's a very good question. We thought about that, and I also thought that it was a very good idea to put this. But at the same time, I was quite impressed on how actually players are very good at making an art by themselves. So instead of constraining them on a specific story structure, we thought like, okay, you create a few sentences in one location, you decide if you want to change the location, you go to another location, and actually they naturally make the transitions. For example, at the end of when they change the location, the final sentence of that location is like, they leave the place. And then they naturally create a transition between locations, and at the end, when they are satisfied by the story, they decide to end the story, and their players are very good at creating an art by themselves, so that's a simplification for a project, which was very good. Thank you.
Thank you, Maria, for the question, and thank you, Mikhail, for the quick answer. Of course, this is a quick and dirty introduction to research, meaning that if you're interested in knowing more about Mikhail and Rafa as well, there's a paper tomorrow, and also you can catch up with them after this late-breaking set of presentations. The next one is coming up immediately. It's Nerva de Monserrat from the University of Alicante. She comes from philosophy, which is pretty unusual in this conference, with a quick and dirty paper about genetic game criticism.
Yes, it's going to be a speed run of the presentation, I think. I'm going to try to apply genetic criticism, which is originally an approach for text analysis to video games. When Espen Arstedt talks about game analysis, he says that in gathering information about the game, we should use as many sources as possible. Playing is essential, but it should be combined with other sources if at all possible. And I wondered, based on this quote, how can we use specific information that we would not know about if we just played the game, but that we would find when we interact with the game as a programmed piece of software when interpreting the game worlds and game narratives. And in my question, I was very much inspired by YouTube videos. This is actually the way I spend my pandemic. YouTube videos by Lance McDonald. He kind of gives his viewers a look behind the scenes of From Software games, so mostly Dark Souls games. He kind of shows alpha versions, individual scenes, and stuff like that. So that's the stuff that I want to talk about. Now, to return to genetic criticism. As I said, originally an approach to text analysis, and it originated in France. And the chief concern of genetic criticism is not the final or the published text, but the reconstruction and analysis of the writing process. Geneticists find endless richness in what they call the avant text, a critical gathering of the writer's notes, sketches, drafts, manuscripts, typescripts, proofs, and correspondence. So, in genetic criticism, the scholars take text to be fluid. A text is not just one published thing, but it exists in more than one version, including the manuscripts of the text, the translations, edits, and even the different adaptations. In the University of Antwerp, where I'm based, there is actually the Beckett Digital Manuscript Project, and they apply genetic criticism to the works of Irish novelist and playwright Samuel Beckett. You can visit the Digital Manuscript Project, it's very interesting, because they very much focus also on earlier drafts and manuscripts of Samuel Beckett's work. And they look like this. Samuel Beckett drew a lot while writing, and he also has a lot of deleted scenes, crossed out text that you can look at. And what for me is very interesting is that the Beckett Digital Manuscript Project takes these drafts, these drawings, whatever he drew in the margins, and uses that info to analyze Beckett's fictional worlds, his narratives, and his characters. And that's the kind of stuff that I'm interested in. Okay, but why am I telling you about Samuel Beckett at the Games Conference? One of the professors in this digital manuscript project about Samuel Beckett says that genetic criticism is ideal to be applied to Samuel Beckett because one of the striking characteristics of Samuel Beckett's works is their extreme ambiguity. which leaves readers in a sort of interpretive limbo. And I thought, well, that's exactly the way I feel when playing Dark Souls. So isn't Dark Souls kind of the Samuel Beckett of video games? Also, genetic criticism has this idea that text exists as a process or multiple versions, that texts are fluid. And I think that video games are possibly even more fluid. They definitely exist in many different versions. When you buy a book by Samuel Beckett, you don't automatically also have the translation of that book or the manuscript that he made while writing that book. But when you buy a video game, you kind of have the different versions of those games as well. You also kind of have different translations, for example. So games do, well, their manuscripts, their translations, their different versions kind of do come with them. You have game select screens, language select screens in games. You have the free practice of patching, which often means that you own different patches of one game. You can even revert it to an older one. And there's also alpha versions, cut content, and stuff like that that could still be detectable within the source code of a game. And in that regard, I want to briefly go into Bailey's treatment of fossils in games. Does anyone know the hot coffee minigame in Grand Theft Auto San Andreas? Yes. So for those who don't know, it was a kind of sex minigame, very explicit sexual content that was deleted from the published version of the game. But the problem was that the coding for the minigame was still very much present in every copy of the game. So Rockstar kind of got into trouble because everybody said that the age rating of the game should be higher because there was an explicit sex minigame in the game. A Rockstar spokesman said that, well, no, this is not very fair because when an artist makes a painting and then doesn't like the first version and paints over the canvas with a new painting, that's kind of the same situation as what happened here. Hackers on the internet just made a program that scratches off the canvas to reveal an earlier draft of the game. But that's actually not part of the game itself. So he said you should not interpret the game based on its earlier draft. In his work on hacks, mods, and Easter eggs, and also fossils, Bailey says, well, this metaphor is very flawed because it completely ignores the digital nature of the games. First of all, the hot coffee minigame could have been removed completely from the source code of the game, but it simply wasn't. It was still detectable within the code. And second of all, when you buy a copy of a painting, you cannot know what was originally under the paint of the original painting. But everybody who bought a copy of Grand Theft Auto San Andreas had in their possession the hot coffee minigame. So it's kind of a different situation. What Bailey seems to suggest here is that games are more fluid than texts and paintings, because very often the creative process and discarded manuscripts are still visible and still present in even copies of the published game. And if this is true, then that would mean that genetic criticism is actually even more legitimate in the field of game analysis than in the field of text analysis, where it originated. But it's very obvious to me that genetic criticism is not really being applied as such, because a lot of people worry about the fact that we would use information that is not to be found within the game to interpret the narrative and the fiction of the game. Now, there are also people who don't care about that at all, and those are kind of the people who do folk game analysis, as the YouTubers I mentioned before. Lance McDonald is an example of someone who does kind of folk genetic game criticism, and I think we could take a cue, we as academics could take a cue from those people. So I just want to give a few examples of what Lance McDonald does and what I would call genetic game criticism. So first of all, there is the mystery of Ocelot in Dark Souls 3. In Dark Souls 3, there's this dragon boss called Osiris, and he is very weird, because when you enter the boss fight, he kind of pretends to be holding something, he pretends to be holding a baby, his son Ocelot, and he talks to the baby, and it's very weird because in the middle of the fight, he kind of yells Ocelot and smashes his hand where the baby should be in to the floor. And players were very confused, like with many things in Dark Souls 3, because of course there was nothing to be seen in his hand, and he's also called the consumed king. So the interpretation of this piece of lore in Dark Souls 3 was that this boss just got so mad that he not only turned into a dragon, but he also started imagining that he had a son in his hand and he was carrying around a baby. But then Last McDonald came out. And Last McDonald discovered an alpha version of this boss fight somewhere in the source code of Dark Souls 3. And the funny thing is, there is actually a baby model, a very detailed model of the baby Ocelot in this alpha version, which means that the designers went through the trouble of designing a model of that baby, which even changes in the middle of the fight when it gets smashed to the floor, because then it becomes all bloody. So a new theory of interpretation originated with this information, namely, the baby is just censored in the final version of the game. It's not supposed to be a fictional, invisible baby, it's just the players couldn't see it because it was a bit too gory to see a baby being smashed into the floor. So also the interpretation of Osiris as a fictional character changed based on this new information. Maybe he's not that bad. He's still turned into a dragon, but he's not merely imagining the baby to be there. The baby truly is there, but we just can't see it because it was censored. Another interesting example is Last McDonald's analysis of Archdragon Peak, which is a city destroyed by dragons in the game. You can see here the final version of the game, and there the alpha version of the game. An interesting thing is what Last McDonald did here was kind of game archaeology. He gained insight into the fictional game world's history through insight into this world's actual design process history. What I mean with this is that the earlier version of this city in the game kind of gives us a clue of how the fictional city that is in the published game used to look like before it was destroyed by dragons, because the models used to be a lot more complete in the alpha version of the game. Now, I quickly go to my takeaways. I think that genetic game criticism could be valuable as a method for the analysis of game worlds and narratives in games. We could, for example, compare the fossils, the cut content, and translations of games to the actual published game that we get into our hands as players. I think we should take a cue from the folk game analysis done on YouTube and Reddit, and I think that there are a lot of particular ways that genetic game critics could collaborate with, of course, source code analysis and the field of archaeogaming. Thank you.
Questions for me? Michael, I'm coming to you from River.
Thank you so much. I understand there's a wealth of research behind this. This is really difficult to summarize. So there seems to be tension, right, between this idea of like the death of the author is a fiction, we shouldn't care, reading is, beauty's in the eye of the beholder, all of that. And that's what I was wondering about in this context, because even if we do the archaeology, unearth the source code and everything like that, how do we know if it was censorship at play, but there was an authorial decision maybe at some point actually would like to tell a slightly different story, or change something in intention to actually tell a different story from what the earlier version was? So do you factor that into consideration?
Thank you. Bringing it in.
Yeah, thank you for that question. I think it's very valid. Also, in the paper that was published in the proceedings, I talk a lot about the intentional fallacy and how we should deal with that with regard to this genetic game criticism approach. And I think that you are definitely right. Whenever we interpret a work, we can only guess what the intentions of the author were, right? Like we have to have it in good faith that what the object shows us means that probably they intended this. And a lot of people say so you should only look at the text because the author is dead, you cannot know for sure what he does, so we should focus on the text when we are analyzing a text, in a game when we are analyzing a game. What I'm saying is not that we should take a different approach to intentions, but that we should take a different approach to what a text or a game actually is. It's not just the published text or game that we should look at, but all of the wealth of information also in the manuscripts, earlier versions, and stuff like that. So I think it's perfectly compatible with this intentional fallacy idea. We should just look at the manuscripts and, in good faith, try to guess what the intentions of the author were based on those.
Many thanks, Neda. Many thanks, Mikhail. There's more information about that in a paper called The Light Game Designer, in which this is further articulated. But now, sometimes for Nicoletta and Petanagapi, and a number of others, actually 3 authors from Tampere University, they're also going to talk about this same project, I think, tomorrow, if I'm not mistaken, so there's going to be a third talk belonging to, no?
No, it's under the Unite project that Matthias said.
Okay, so just another talk by Tampere, non-related to this. Nicoletta, good luck.
Thank you so much. Hello everyone, my name is Abeta and I'm here to present the Unified Educational Software for Data Literacy and Research through Design approach for Canada. So, I will start. First, please let me introduce you to Canada. Okay, Canada is well known, but in this presentation, Canada is my individual fellowship project and it's the initiative of unification and verification towards learning forecasting. And what this project is about. We all know that the data increased. There's a plethora of data matrix. Up to 2010, there were 3 zettabytes of data, which means 3 billion of terabytes. We understand the amount of this data. And from 2010 up to 2018, we are having 33 zettabytes of data, and the pace is only about to increase. This is not a problem. This could be even an opportunity in order to have a data-based worldview, which means to understand what is happening in our world, which is a very great opportunity. What is the problem though, and this problem that this project tries to solve? It is that people still are discouraged and not so motivated whenever it comes to data-related projects. Okay, maybe engineering could not be a very good example. However, even students in introduction statistics course, they are not so motivated with this kind of concept, let alone the general audience, which is the target group of this course, of this project, I'm sorry. So the aim of Gamma, it was to design and implement a gamified software, but not only tries to motivate general audience and citizens in order to have an understanding of the data, but also tries to compare different motivational affordances in order to see what is the most effective one. Okay, it was good. The problem was that, actually not the problem, the good thing, the fortunate thing it was that this project got funded and then I had to do it. And this is exactly the reason that I came here to present it. Because I'm very used to do this research through science approach, according to Data 2014, which is, okay, we're having a strong hypothesis, I implement the software, and then I'm having a very good factorial design experiment, and I'm having some results that I'm trying to replicate, and it's very well organized. However, today, I'm here to present you a research through design approach, which means that we have a very nebulous expectation. We knew what we want to achieve, the learning objectives and everything. However, the design process is not exactly step by step. There are a lot of problems that occur. So today, I'm here to present you this design journey, and more or less to tell you the problems that we have to deal with. Don't worry, it's not a therapy session. I will go through this GABA 2014 approach, which is very well structured, and I will start presenting this design process by exploring the context. So, first of all, this application was about exploratory data analysis. This was the educational context behind this. Okay, we said that we will follow talking book, and we will take some concepts for that, because it's a very well-known book. Good. The second thing was that we have to have clear aesthetics of the application. So, this is here, my desk, how it used to look, Matthias knows. For 2 months, whoever was passing by, I was okay, I'm having this project here in CSAT, please make a logo or something that it's about to be. And then I have to create a kind of prototype using a sign because I'm more experienced in this thing, and I did a very strong session with some implementation experts in order to see, okay, what are the main aspects that we need to include in this application. And we found out that, okay, we need to use individual gamification elements because this is the research that existed back then. And then we need to have clear guidance because it's an educational software. We need to use layman terminology. Everyone in statistics do not understand the words that we are using. And then we need to have a clear experiment design. So, the second phase of the design process, it was to develop a design space. This means, first of all, we need to have clear educational content. Okay, what are the learning objectives? What are the topics that we are going to teach? And after that, what are the data that's about to present? Because we wanted real data, surprising data that are about sustainability, and everyone is interested in this in order to understand the statistical concepts. This was the motivation per se. And then we said, okay, we're going to gamification design. Let's take these 3 different gamification types that in CHIP 2020 they said that, okay, these different gamification types design affect satisfy needs in a different way. And so we use challenge-based gamification, but we took only one motivational affordance, but badges, and then version-based gamification, which we do storyline, a storyline that the user is a participant in that, and then social-based gamification that we use competition. And as a last part, we use art and assigning and higher scale design, because the idea is that this can be used in statistics courses, and most of the statisticians are very experienced in this language, and also we could have it online later on in order to support open source society. And the last part is the refinement and the making. So we make a prototyping, we have different kind of data, different kind of visualization tools, and also different interactive tools and warm-up sessions, and people, participants should answer in these questions. We use prototyping sessions, so we have some experts from gamification and experts from economics, in order to get feedback and then redesign and re-implement based on their feedback. Finally, the software was ready. Of course, there are some bugs, but still it's ready, it's online. And we did random assignment between 4 different versions, a baseline version which has no gamification, and 3 different gamification types, as I have already mentioned. We use it in a series of courses. National Technical University of Athens, University of Pretoria, South Africa, other universities, a lot of other universities. We had a total sample of 181 students, and apart from that, we have also entered users because that database is general public. It more or less resulted in an improvement of 44%. This comes out from a pre and a post test before the random assignment and after the intervention, and a full round in this game, in this application. Let's say unified application, it takes around 1 hour. But I will not stay presenting that. I will focus more on some feedback that I got for some entered users and some students, that you can see there, that okay, this was super cool, or please, there were students from National Technical University that sent a lot of comments, okay, you can change that, and this was pretty cool there, and so on. Thank you. Of course, there were other problems during the design process, which was data should be very well encrypted, and of course, if I was about to do it now, I would like to be able to update the data through buttons, not through the database that I'm doing now. And to conclude, and not taking more time, I would like to mention the design consideration, which is more or less the lesson learned from this design, research to design process, which is, first of all, that designing is a multidisciplinary and very complex process, which means that it includes a lot of different disciplines. It is education, it is design, it is game studies, it is also software implementation, and also the design needs different kind of expertise. It was a very good thing that I had the opportunity to involve game designers, game experts, and also economic experts, because it was a multidisciplinary area, as already said. Another element, and I would say that it's very important, is the design. It's actually the unity vision. I think that it was a very important topic that I was able to design the application and also to implement the application to the application, and that I was able to have a lot of different sessions with an art studio that helped a lot to make all the graphics of this application. The reason is that based on that, everything was unified, because all the design was interwoven with the statistical concept and also with the progress inside of the game. And finally, I would like to underline the importance of the progress, because it is, apart from a very important topic in education, it was also very important to this progress to be underlined through the game design and through the statistical complex concepts that we are about to be taught. Thank you so much, and please, I don't know about this.
You didn't mean too good, you had 1 minute to spare. Yeah. You can breathe. So, do we have questions about this gamified way to understand statistical concepts? Is that, I'm going to get you the mic.
Hi, fantastic talk, thanks. So you mentioned you use COVID-19
COVID-19 data as a baseline for this. Do you use other data, or are you planning to modularize your system so that maybe like a teacher could import their own data set and have their students learn to analyze it as they need it?
Yes. Just to be sure that I understood correctly the question, I use data from online databases, from our world of data, from Capminder, from different databases, and everything is open source, of course, that I was able to use. And I have made already some questions, so there are interactive tools inside that they analyze automatically this kind of data, and students then use them. I would like to have this update button that can automatically with an app in order to take this data, in order for this application to be updated, because one of the main components was that, okay, I can use it in every year lecture. This is the only thing that needs to be somehow integrated. So, yeah, and the idea is that, and the topics of the data is about, for example, gender gap, it's about forestry, and this is how it is connected to the Unite, as we mentioned before, and it's about COVID data, because this was another problem, that COVID happened in between, so I had to redesign all the application again, because everything should be online, but everything was important because of that also, that it is COVID related, so it was a little bit more interesting. Thank you for the question.
Thank you, and I wanted to thank all the speakers today. Very timely. I know this is a brutal kind of session, but yeah, you all managed. We all survived, and got interested in new ideas and got inspired by a number of activities. So many thanks to everybody, and I will leave room for the next session.
Thank you.
Thank you
So
so
you've
much
been
for the
super
very
quick.
nice.
Did you finish your piece?
This is a postdoc plan. I finished my PhD though through the Mercury Asimopoulos from National Technical University of Athens, and we were collaborating with postdocs. Thank you so much.
Let me see the program. Stefano, we have a session with remote participants.
And this,
I have no idea.
what is it? Just because I believe even sessions for everybody, so. What is it?
LBW.
LBW, so this could be ERO.
Okay.
Or, no, maybe I think it might be. Oh, I gotta look for a chair, or I'm gonna chair.
Until somebody else shows up, at least yeah.
We have no remote viewers now.
No remote viewers.
No one was.
Well, I mean, they should come because we have the online thing. Right?
There's something something with the links.
So
I don't
we,
have my phone to check the Discord or
no,
anything.
yeah, we just have this one. So that's fine. I don't know who's sharing it, but if they don't show up, that's gonna be fine. Hi, how's it going? Sorry? There's gonna be an online session now, but straight after.
Yeah, sure.
Do you want to use your computer?
Yeah.
Okay, yeah. Yeah. So
It's just as HDMI, right?
Yeah,
So I just
HDMI.
plug it in. I think it's
Super easy.
Yeah.
It's gonna be, we need Costas now because we need to use his
Zoom.
Zoom, exactly. Okay, so
Oh, does that mean, well, what kind of computer should I transfer my?
if that would be a lot nicer. I mean, if you could like give me your presentation and see if it runs from here like naturally. If you want to use yours, we need to log in with Costas Zoom because
Online.
that's how. Yes,
I see,
because
that's how
how-
we're gonna share it. I have Zoom here. Okay, good.
It's your decision.
Do you think we'll have time to do this right after the next session?
Absolutely, you have time to do whatever. Like, also, we can delay it until you're ready. And
Yeah, sure. So right after the next session, we can start. Okay, sounds good.
greetings.
If I send in the slides to, who should I send it to? Your post
I would say that if you send them to Costas, I can see that Costas is logged in with Google. So, yeah.
Okay. And did your speakers just sit down or did you stand?
It depends. Like, did you hear? Like, it's a bit. This is very loud.
Yeah,
right?
it's not.
And so, like, it would be awesome to speak like this, like protected from the reverberation.
I see.
So
Sitting
seated.
down would be easier because if I can see the screen.
If you want, I can even hold the.
It's fine. I just have this. I can put it.
I hope you're gonna get a large-ish audience because also the tech people will join us.
I know it's tricky.
Yeah, you never know what they do. Okay. I need to start this one now.
Okay, sure.
I will see you in a second. Greetings, everybody. Hello. Now, we have an online late breaking work session starting right now, and we have, sadly, or not sadly, really, 4 online sessions. And I am trying to figure out if you're all here. Actually, let me see. The first one would be, the first person is not even here. So let us not waste time. And Mehmet Koza and Peter Sprong are also not here. So that's great. So Tassos Papagiannis, are you here and are you willing and ready to present?
Tassos Papagiannis. Of course, and after Tassos, we also have Vlasios Kazapakis. Vlasios, are you there and are you willing to, or are you going to be ready to present eventually? Okay, perfect. So the idea here is that a late-breaking work is normally quite a quick session of a lot of papers. And many of the authors for this session, for whatever reason, didn't show up, meaning that we could take it a little easier with just the two of us, meaning the presentation of Tassos to begin with, and the colleague of Dr. Kazapakis. Is it pronounced correctly? I suppose so. So, Tassos, whenever you think it's the right time, you can, I would say, make your camera visible, and also I'm going to give you the possibility to share a screen by making you host. Okay, let me see if that is possible. I'm almost there. I'm gonna, multiple participants can share simultaneously. Mehmet Koza is also online. Mehmet, welcome. You are supposed to be one of the first presenters. Hi, Mehmet. So if it's okay with everybody, I would start with Mehmet sharing his screen and starting his talk. As you know, the late-breaking works are quite brutal. So that means that you only have 10 minutes to explain a lot of research normally. I will try to keep everything timely, so about 10 minutes of presentation and 5 minutes of questions and answers. So Mehmet, are you ready?
Yeah, just a second. What's up? Real quick, and
Please share the screen whenever you're ready.
yeah,
I can see. Right. And you should be able to share the screen. You have the rights to do so. If not, I will make you a host. Perfect.
is it showing up now?
That is, and I'm gonna also share my screen here. So everybody in the room sees you in a second. Not yet. Just 1 second. I should be able to do it now. No, I need to visualize this. Costas, do you know how I can make this? Just a second, Merit. Do you know how I can make this one the main screen? Okay, sure. But it's not going on. Do you see what I mean? Like it's not on the main screen. Okay. Is everybody seeing? Have we not seen that screen? Sadly. Have to duplicate. Okay, now we get it. Mehmet, whenever you are ready, you can start with your talk.
Okay, alright, thank you. So you can hear me, see me well? Okay, great. So, hi everybody, I'm Mehmet Costa, and I'm the postdoctoral Research Associate at Northeast University. As of now, the study we conducted either around September. I know it's going to study on the purchase intention of modern board games. So this is kind of a continuation of a larger board games project that we were doing in the work that first was actually published at FPG as well. But paying attention towards hybrid board games, and then the second one was about foundation towards analog board game games. Third one is about purchase intentions of players. So what did we look at this study? Why we looked at it? So we looked at demographics. First of all, age. So we looked at the literature, about the age purchase intention. There's some stuff there about both young people might buy more and older people might buy more depending on the context or the domain of the product. So we didn't have any like policies about this, but we wanted to look into how board games actually can be related to age, purchase intentions for board games, and then gender. So we saw that there are some studies that show that gender might affect purchase intentions in different domains, and then some of the recent studies in the working domain talks about how that's where the game is identified as male. But we thought this might not be the case for purchase intentions. One gender having more represented more in the industry or in the player base, so we did that as well. And then income was kind of a no-brainer to include because you have more disposable income or more money, you tend to spend more, so we included that as well. So prior experience we thought might be affecting purchase intentions of board games. This is a line of literature saying that as you get more experience in a game, you tend to purchase more. Another variables we included was enjoyment, which is study a lot. If you enjoy something, probably you want to buy more of it. And then also the word of mouth was another one that we included because it seems that hearing from your friends and family or your viewers say that the game is good, I'd actually increase trust in this increase, so we included that as well. Presence we thought would be interesting, might be one of the factors contributing to it. Lately, some of the studies were talking about how board games also vary versus qualities, which eventually would give it some presence, so we included that as well. And then finally, pregnancy we thought might be one of the other factors that we didn't have any background from this, but we'll use it, so we included that as well. Method-wise, we conducted an online survey on countries and then announced the study of board game system. With this is collected in 2018. We had 867 participants, where more than 700 was close to 40 on average, and then more than half of the players were residing in the United States. What was very nice that we were able to collect data from 53 different countries.
There's something wrong. It was a lot more people couldn't get in.
I wonder.
So this is the correlation matrix for our variables. I wanted to talk about obviously it's just we can just focus on the yellow row, which is the intention to purchase, just focus on this study. We can see that on the right hand side, intention to purchase was correlated with enjoyment of the amount, and then a small approach to the third column with income. But then when we put the solve together in a multiple regression. We saw that income disappeared, that age became the front, and then it turned that wasn't going to persistent. So basically, we saw a very important factor among those variables, purchase intentions. So age, meaning that as people get older, they tend to buy and pay more. It's not a very strong effect, but still. But then I think that people get older because they get more money, so they can buy more, but then the income is not significant. So that causes that explanation. So another explanation might be that people seem to have maybe more free time, so they can buy more, play more. Gender-wise, we saw that there's like this really small effect, but it was also a big 0.05 significance level, which just said that this is not conclusive. The paper would say that it's really negligible, but it's equal and conclusive, basically more studies are needed to see that. But there's actually not a lot of reasons to believe that gender will affect purchase intentions. But we still agree with that. And then typically some products because it did not affect at all. So game players might be just as much willing as the players to buy more games. This data shows that. And then presence was not affecting that as well. Well, presence might be also dependent on neutral. Again, as we can see, the primary factors among these international so people buy more if they enjoy this home, and then they advised by preference or the viewers online tend to buy more. So there are some limitations which calls for some mutual work. So first of all, that this study was cross-sectional and was on the heavily ski set for both generalists. Also, the only captured on planetary activities are drugs, those forms that we announced the study on. And then we didn't have any data on product purchases or purchase intentions. We didn't have any data on what types of games they were buying already. We didn't know about their buying behaviors, whether they answered the questions, thinking online buying or offline in the store, the board game store. So these are the things that we were lacking, where future studies might address. So this is all I have to say about our study. Thank you for listening. I'm glad to hear comments and questions.
Mehmet, thank you so much. We are in a room and we're having a bit of difficulties with audio. Thankfully, we understood everything that you said, but we don't have time for further questions. Also, there was something that was not clear concerning Zoom, in the sense that somebody is in a different room, including John P. Haley, I suppose, who managed to come here. So I suppose that we should just move along and have John be the next presenter. He should have been their first one, but of course there was a mishap with Zoom. John, please share your screen whenever you're ready, and let's get this presentation going. John, if you're talking, I don't hear you yet. I can hear you perfectly. Sorry, I don't know what happened because I just sat in this room, which is normally connected to the same old Zoom, and it was not the right address. So, but you're here now, and let's get started.
Okay, great. Thanks very much. Apologies for that as well. So this paper is ongoing. So the longer we looked at the students who treat and game design process. I'm going to try to keep this quite brief. We're going to have 15 minutes, and that's kind of time schedule. So to start off, I'm going to give a little bit of background. So we're coming from the study that give some examples of what we've had and where we work from here. So
This specific study is part of a bigger project. I presented a couple of things that we've seen over the past 2 days here at FPG, which is kind of looking at game design and what is happening in game design and what game designers are doing. And I don't know if this is unique to game design, you look at like product design or graphic design, there's a lot of research in this area exploring like how design happens in practice. So my background is as a product designer, and this is called how do you design, or like it's kind of common. But it is a sketch which I think is very useful. It's a sketch done by Ken Brown at Apple in the early 1990s. And he was asked, like, what does the design process look like? He said, we start off with a question, we go through some sort of convoluted process, and it's declared like all these squiggly lines, and eventually we end up with a problem that people want. Yeah, so within game design, like, the question is what's happening within those squiggly lines. The overall project is looking through 3 different lenses. We're looking at people, so we're looking at designers and engineers. This specific study is looking at the process, the classroom observations, and analyzing student development models. And then design methodology, so looking at visual outputs of design and analyzing how maybe we see impact design practice on products themselves. To get into the study design as briefly as I can, this is all covered in the paper, so maybe like last week was starting to like focus a little bit more on some content in the future. But this project is a 6-week development project in a Unity and module that looks at game game design. The study took place just completed in May of 2022, so just the spring semester. And at this stage of the program, students have one that will ask for game design and production data, but 6 weeks of the construction prior to the project. We use field notes and deadlines to gather the data. I think deadlines are actually a really rich source of data, really trusted with the design process. And I think that was really useful to look at those. So we used prior period functions with 32 minutes, that's at 18 to 19%. Within the prior period, we did line by line coding. Initially, we had 236 codes. We found 6 main themes came out of this coding process, and then 20 sub-themes. So what we're exploring today is some of the sub-themes and lists. And these are specifically the approaches to design that we saw the students involved in our projects. So the first one was open-ended design. We also saw the entire experience of moral design and technical design. Some of these are broad areas that we use. They were more interested in the context of game design as a discipline that interfaces with a lot of other disciplines. Another thing to be aware of is sometimes, as in things like player experience design and interface with world design or technical design. So these are not mutually exclusive goals of design, rather they're complementary together. So the first one is open-ended design, and this is probably the design the most familiar with. This is like media in terms of the general design process. Coming up with high-level concepts, lots of work about feasibility, but not really ideas that are interesting space to explore. The quote here is that team one, and so we were discussing what ideas would work for us to make the game that fit the genre. But we were able to briefly start to make the discovery and ideas that would make again. We came up with different key ideas and tried to work with ideas. We created our first brief concept in the PowerPoint, and thereafter, towards the end of the week, we worked on our first concept working. And this shows that we want to focus on interesting ideas and the concepts of being improvements. You're not encountering obstacles in the way being designed based on a ladder. It's not very open-ended, and it's up to them as a design team. The next one is player experience design. And this is very much kind of design for someone else, for a hypothetical player or like testing their games. And it's thinking in this whole hypothetical designs across the speed. And think about how some person wants to choose. And think about how they would interact with anyone else. So here we have team 4, 5, 6, some lighting these against the player. Direction in the game world. Players are taking elements that certain lighting used to recognize specific game objects as well as suspension. The hope is that the player will understand the meaning of the visual language and will use it all distinctively, creating a more
share their experience. And I think what's interesting is we see the players making not from themselves, or it's not about their idea of what they're doing, instead they're trying to think of how that this player will engage with the design and creative. And that's kind of the unique part of the player experience design. The next one is world design, which encompasses an awful lot. There's a lot of disciplines like art, the visual design, level design, narrative design, building environment, virtual worlds, basically. And it's how you create these virtual worlds and settings for the game. There's an awful lot on this one, but at the same time, the long term is very focused on the concept and focusing on building out that part. So here, in the from team 2 and team 1, we also decided to split the game into different sections, a tutorial, a learning, a course learning, and then finally a testing period. Each set of levels will have its own color scheme to make it easy to understand. Also here, there's a technical about the level design and progression within that world of the game, but then also the visuals and how that visually communicates to players as well. So again, this kind of gives the player experience design, which is alongside their certain elements working together. And the last one that we saw, last kind of approach we saw is influence technical design. And this, I think, is something that's at times easy to overlook, and I don't think I might focus on too much. But it involves the numerous interactions between design and creation. This often has a lot to do with the tools and experience of overarching design goals. I think one really interesting thing is a lot of students in the first couple of weeks talk about creation and maybe basically web to controls and then creating their own mechanics. So it's interesting that there's these standard mechanics with all our expectations and then students can build on and create their own work. So here we go from team 2. Before I got the LD system in, I could find out the players doing each other doing that. And I interacted with one and made some checks to see if the players were colliding with each other. Then I made sure that there was a set of the chance that they do got rid of their bridge values so they could evolve and change their position. So the rest of them have to be on the back. While you look until I make one function of the to their back, the bridge value came on the back. And so here there's only technical steps that have to be completed. Some of them are straightforward, right ones, and then you have complex maybe cancel or create exact actions as well. And I think what's interesting about this is we saw these happening within this evolving the design process that we've been working on. At DIGRA earlier this summer, we presented this model of exhibitions of a problem solution. It basically lists this probably loss sample design in general and considers what that might mean in terms of game design. This study helped us kind of look beyond this a little bit to see what's maybe interesting about games. And I think some of the key things we saw is first in context of team work, team working with other developers as well. And it really changed how the students explored their outcomes and what they were capable of doing, impacted on the people, the team, the data, even what media experiences they had before those. The other with building references to from like I said, the problem, the solution, with the initiation and outcome. Sometimes students just want to have something to the game they thought might be good, but seen as an initiation. Other times there were bugs in the game that they didn't have time to fix, so they couldn't necessarily fix. That was just different, it was better than it was. And these approaches, like I've been previous slides, all have this kind of cycle, very often analysis, sepsis, and automation happening within each process. We saw very much the standard tools and techniques that design to be worked by our students. Very briefly to go through some limitations. This is a single cohort within a specific program. It might not be general to another educated public resources, but you're going to let people think about how this applies to their own practice. Developments as a data source can also professionalize and help, so the students aren't necessarily like, I'm not analyzing individual design session, but rather they're reflecting and kind of professionalizing how we want to describe it. And it captures that over an entire project as opposed to individual decision points within that process. And I think some of the conclusions I think is the students of marketing is really complex design journey with making games. I think it's easier than it to not realize the complexity of the task, especially because there's an awful lot going on. And it made us wonder if it's possible to isolate some aspects of the process to focus on skills in specific areas. It's fine to say, we get a better design for getting experience in making games, but compact and it's also something that we're making it. So that would be lots of elements. The other thing is that game designers and architects move much quicker to ideas and concepts, like they move much quicker to set something still by expecting the design relationship from other areas. I think that's because there's this huge technical implementation burden on game design students that they have to be and have to be right. That any other design discipline isn't. And then future work from this, what we're going to do is we're going to look at existing games, we're going to start off with that game and look at specifically how to design this game with some of the technical features that we're going to design this, and what we might be able to learn from understanding the overall design process and the different team members and their perspectives. That is it.
Many thanks, John. You've been very timely and very quick. And again, we are on a very tight schedule. So I would like to ask you to please stop sharing your screen and let me invite the next speaker, which, if I'm not mistaken, should be Tassos Papayenos. Tassos, if you're ready and willing to share your screen and give us your 10-minute talk, that would be fantastic. Please. Tassos, you are muted, so please unmute yourself. So I suggest that we maybe run maybe Flazos first. So while you fix your technical issue, what do you think? You think you can fix it immediately? It's working now. Okay, please go ahead.
States design plays grabbing national education of the gameplay of current statements. So this is another way of presentation. First, we're going to the technical demo of current systems algorithm and the rapid national education. Then the proposed variants, namely the network-based maybe, and the concept of the representative, along with the results we obtained from the experiments. And finally, we're going to everybody discuss some potential extensions of the program in the future. So let's start with the introduction of the current concepts. First of all, the goal of our work is to create general images based on the main requirement of the current research algorithm. Current research is a simulation-based set algorithm for decision problems, which is also communicated in the context of game artificial intelligence. And during the process of the algorithm, an aesthetic game is built in a way that various represent the possible actions and makes its node present each state that sees the execution of certain action. Now the algorithm can be broken down for main steps, which are explained immediately until the timing is fixed. And that will be the following steps. The first step is the selection. Three nodes are traversed during selection formula until the non-relation node is fixed. Then in the expansion step, a new node is created. It is inserted in the tree representing a new action. After that, the simulation takes place from this new node until the terminal state is fixed. And in the final step, the output simulation is followed by the development node. Now, when we set there is a 10-minute interaction, which means that nodes that are deep in the set situation are also selected very often. And that leads using high value values. So in order to work out this, in the architecture value estimation approach, a heuristic called columns as values is introduced. And actions are valued even when they select given in the tree. And then this heuristic is integrated in the selection formula in order to help upgrade faster in nodes. However, in this case, the values of the nodes that are getting the use of the tree are still based on the two samples, and they continue to suffer from high variance. So, a key idea for the this is to not use the amount scores of the node we want to evaluate, but instead we use the amount scores of accepted nodes, because these nodes are higher than the tree, and thus they are little more favorably, and they can be considered more reliable. So, in this direction, two more approaches have been proposed. The great variant, which uses the amount scores of the closest ancestor, it has been basically more values than the specified threshold, and thus can be considered reliable. And then the variant, which always uses the amount scores of the root node, which is the highest probability and the visit every time. Now, therefore, we just take this idea of further, and determine the balance of the node for using its amount scores selection. So, the main idea is that statistics of nodes of similar state are probably the most common for this method. And so for our nodes, the goal is to find the best matching node depending on state similarity, and then use the amount scores of this node in the selection formula. So we propose two different variants based on state similarity. The first one is the element-based array, so let's take a look at that first. Okay, so in the context of being AI, an element is basically a sequence of concepts of functions. And in most of the cases, states which are reached by the same element are quite similar. So this approach, we try to determine state similarity based on the natural sequences that led to the corresponding game states, and then determine the best matching node as the one with the largest identical element, the one with the node trying to evaluate. Here an example of this process to find the best matching node in the element-based array. So in this example, imagine we want to evaluate node I, which is not yet down here. And so much because we look for nodes higher in the tree that are reached by the same sequence of actions as this node. Now, in this example, the largest identical element that can be found in the tree consists of two actions, namely the action tree followed by action 2. And in this specific case, there are two different nodes in the tree that can be reached by the same node. These are nodes K and node J, which are also right. So, because there can be one number of candidate best matching nodes, we propose three different approaches for dynamics-based array. In the first case, we always select the node higher in the set tree as the best matching node, because this one will be basically the possible times. In the second case, we already start supporting the nodes in case there are lower than 1. And in the third approach, we always look for elements of fixed size in order to also decrease the time it's consumed in the search process of the best matching node. Specifically in that case, because we have a quite strict time limit, we're going to look for elements of size 2 and size 1. Now, the next approach was based on similarity is the concept array. Now, in this case, the goal is also known for using some hard scores based on the game states similarity. And the difference here is that in this case, the similarity based on the frequency of the actions that was affected, rather than the exact sequence of actions. And that's because in several cases, the raw production does not necessarily affect the final state. So, in this approach, we only care about the highest number of the identical actions selected, despite the order. So, as mentioned, we always look for ancestor nodes. It means nodes that are higher precisely than the node we currently evaluate. And these nodes usually result from shorter paths, which means that nodes that are in different depths of the tree are usually much less very similar, since we only compare the appearance, the number of appearances of actions, in order to demonstrate similarity. And now, in order to overcome this problem, we take advantage of the fact that always the heading actions basically cancel each other out, in the sense that if the node like the mathematical state, so instead of counting the appearances of the actions, we prefer to calculate the value for this class. And this way, even for nodes that have a last distance the given tree, the algebraic values can be quite similar, and we're able to determine the best master node using these frequency methods. Okay, so now let's take a look at the results.
Tassos, you know that this is a late-breaking paper sessions, meaning that you were supposed to present for about 10 minutes. If you could go to your conclusions, maybe we can have a question here.
Okay, one is to just present the results. So the mean rates of our ratings, the investment in the several different games, and these are the average scores. So I'm going to say that the average of very well in both in getting scores. So we're going to skip this quick. So we presented two rate when we have research business test value. Then only determine similar states depending on the action view, and define the best master node using some of scores. Concerning the performance of ratings, the following were in terms of weights and governance scores. And some of these conclusions are essential to be, first of all, to test the names, test our approaches, including the time matching platform, done by the ones that we invested in the building reviews. And then we combine the values of the best master node with the values of other ancestor nodes. And finally, we integrate also the main node in our ratings in order to further improve the performance. So that will be all for attention.
Thank you, Tassos. And we have 11 participants online and a handful here in the group. Let me see if we have any questions concerning your research paper. It doesn't look like it in the room. Anybody in the chat is interested in furthering into Tassos' idea? Doesn't look like it, so either you've been very, very clear or everybody is asleep. But now it's time for Lina to take over. This is the last session of a quick fire, late-breaking papers, meaning that you're supposed to be very, very quick, go to the core of your research, and hopefully we can get a couple of questions in. So Lina, please take it over. Yeah.
So this study is part of my research because I'm looking into VR research methodology as well as VR experience design and organization. We conduct a multitude of experiments that are very small scale and very specific. Here we looked at how feedback affects users' perception and non-playing characters. So there's a variety of feedback that can be provided in immersive VR experiences. We're looking into haptic and most VR systems tend to use micro-tactile feedback with the use of dialogues or vests. And upon collision, usually the block vibrates and communicates something to users. Many slides have been adapted on that front, regarding both other type of feedbacks, feedback how it affects users, and as well as haptic feedback. And those slides include either NPC facial cues or interactions or, of course, vibrations, touching each other or being in close proximity, have some kind of emotional effect or maybe has sense of environment or sense of co-presence between users and NPCs or other users who are multiverse. What we wanted to add specifically was not exactly what users think about themselves when they're providing some kind of haptic feedback, but how they believe the other entity perceives them. So what are the supposed thoughts and emotions of the other entity? And so this is mostly about my reading how the other entity is experiencing this interaction. That is why we designed a very simple experiment. We acquired from Mixamo a very generic model, specifically the humanoid non-player character named whiteboard NPC model. And we also find animations using Mixamo. And we called participants, and they were equipped with HTC 5 for HAT at Mount Display, as well as Mount VR and Pro. And designed a very simple environment in Unity. So this is a short GIF of the experience. Our scenario instructed participants to observe their surroundings for a few seconds, and then they attempted to touch the NPC's left hand, and the NPC was updated to upon collision to pull their hand back and directly with participants. And after 10 seconds, a green box appears on the left side of the participants, and they were again instructed to touch the box. As they are approaching the box, so does the NPC. And we're going to keep going back and forth until their hands collide. And then again, the NPC looks at the participants. But as you can see, it doesn't have any eyes. It's a bit difficult to determine whether it's male or female, and the environment is also very minimalistic, and there's nothing in it. The purpose of that was to have participants specifically focus on the haptic aspect of the interaction and not be distracted by other kind of signifiers or social components of the interaction. So yeah, there are no objects or colors or other elements. There was also a question regarding the size of the environment, so we also tried to make this vague, and it's kind of difficult to establish how big the environment is. So in total, we had 30 participants, and this was a 15-group study. So 50 participants were the no haptic feedback group, and 15 of them were the full haptic feedback group. So they all have the capacity to move their hands and supposedly touch the NPC, but only one group receives haptic feedback upon collision between the objects. Most participants were students, 24 years of age on average. Okay, so aside from some questions that I asked them, participants were also equipped with an empathical risk mount, I think it's called like this, which measures heart rate and electrical activity, and all sessions were recorded, as you can see on the screen in this moment. and we got to record all those measurements. As soon as this little script is finished, I will now allow participants to take off their HMD, so they're still in the environment and looking at the ABC. But what I did was ask them 7 rapid questions without giving them any time to contemplate or think about their answers. So briefly, they were asking whether they believe the ABC to be male or female, whether they perceive the ABC to be scared or annoyed or touched, whether they themselves like or dislike the ABC, and vice versa, whether the ABC wants to be touched, how hospitable or inhospitable is the surrounding environment, and whether it's big or small. And I'm sorry, I should have skipped that. So we know the last answers do not have a very big differentiation. There is an interesting clip between the concept of the ABC being male or female, and this can be correlated to possibly body cognition, so that the group that had that received happy feedback also tended to believe that the ABC was female, and also they were more inclined to give a better evaluation of the ABC's probably emotions during the interaction. This is just an idea of how we measure the Impactus collected data. So basically, we sorry, I have the next one. We register anytime there is a skin conductance response, and then we evaluate the differentiations upon the first touch. So the first time participants touch the ABC, we then begin counting what's the occasion of SCRs. And there's a differentiation more for the group that had feedback were responsive, and also the frequency of the skin conductance was higher. In essence, the group with happy feedback was more affected by the touch. There were also differences in heart rate measurements. Incorporating happy feedback did not affect how participants, how much they like or dislike the ABC. But we did change what was our initial question, so how they believe the ABC themselves experience this interaction. So they consider the ABC to be more scared than annoyed. They believe the ABC to be more light on them, or in the case when there was happy feedback provided. The second group of happy feedback also were generally comfortable in the environment. And our studies called first impressions matter, and basically we consider that when an NPC and a user are first interacting, that feedback is richer, it might affect the way that users evaluate this experience and the type of emotional state they find themselves and then with the other entity. So yeah, it may have a positive effect, but for us it's more about the question of how do we conduct this type of small-scale research to understand what sort of feedback we strategically put in applications and games, so that we can induce specific emotions and feelings in users and participants and players. So that's it for me. Thank you very much. I'm going to questions.
Elena, this was very clear and very timely. I thank you for that. Let me scan the room for questions and the chat for questions. No takers in vibro-tactile feedback as a way to make sense of virtual encounters. And the chat is also not responding with questions for you. So, Elena, it was a pleasure. It was very clear, and for whoever is interested, the late-breaking works will also be available as papers in the proceedings of the conference. So, in case you're interested to further your knowledge about any of the treated topics today, you can definitely continue there. Next up, in a few minutes, we're going to have the keynote, meaning that we need the preparations, and the next few minutes are going to be used for that. Thank you very much for whoever followed, and I'm going to go mute. Okay. Costas, do we have a coffee break next? What happened with the Zoom? What happened with Zoom? A lot of people were in a different Zoom.
Yeah, I'm not sure what happened.
So you're gonna take care of.
I posted it on Discord. Yeah.
So we make sure. Is it in an hour or is it now?
It's now. It's in 5 minutes.
So I'm gonna take a break and I'm gonna call everybody in.
Because do you want me to? Is there for some reason the internet's not working here, but do you want me to email it? If you have a Windows machine, I guess I can do it from here.
Yeah.
Or can we connect?
Maybe.
Can we connect to Zoom from my computer? That would, I mean, my computer would be safest, but I can. This is.
You can use your USB stick to copy it?
Yeah, I can. We can use that. Let's see if that works. Do you have what version of PowerPoint do you have here? Do you have pretty recent one? I'll give you the. Yeah, it's expired.
Yeah, we'll take it out after that, yeah.
Because this is connected to Zoom, right?
Right.
Okay. It's just only one file on there, I think.
I'm waiting for.
Okay. Yep. I'll just run through it and make sure it's okay.
Oh, it's just the case study.
Yes, yes, it is. Should I just click on the mouse? People are doing?
Yeah, do you want me to get a remote control?
No, it's, I mean, Stefan said I should probably sit down because of the mic situation.
Yeah.
Is that better? Oh, please probably. Then I think I'll just sit down with this.
This mic is connected to Zoom, so it should be okay.
Yeah, it's fine.
Okay. So I'll just check on the second floor.
Okay. Is there a...
Ma non è semplice, tu dopo c'è che cosa adesso. Ok, il microfono che tu
chairing an online session in which I have people who watch a lot of programs, so they will be
That's really fantastic. Yeah, but couldn't you just submit it to your
There was also recently because somebody said the to write. So you need to be at the right distance now or not. Because it was that I think
Yes, everything is more console underneath here. Hey, I like Chris, what did you mention a project with dolphins?
Yes.
What is that?
I think it's the main research.
Like, what's the pitch?
Which is that there are captive dolphins in London, and nobody's very much able to hear about how it's like a gay life, something like that. So, in collaboration with research, which is the beginning process. Maybe, what is like sessions, other really one ways that they find it will be that we have a trainers, different types of some with color, some with flavor, and so on. And at the end we came up with a very manageable that is very useful for publishing hopefully something we can need to be but there's no continuous. So it's actually not feasible to always get sort of flavors and notes that we use. And we've done the same things with the stray cats. Sort of like cats that need to go to physical therapy and get them moved. And so they give them some tasks to check and it's and this is kind of
But also, just as a game design case, so you're forced to completely personalize what you can and your personal assumption as to what might be the better profile.
You need to be very open-minded.
That's totally attentive for real, like.
You can capture the index inside, because it's not really a document of me, like, you know, like position, distance, how you can detect something very exciting from the it's like, how, I mean, are they having fun?
Are you angry?
So it's people like how much they interact, like how much they agree with doing that. If they see toys, how many times they do it, how many times they try to do it. So number of interactions, frequency of interactions, what you're exactly. And it's probably symmetrically to small tools. This one particular stuff, the one of all things like the hands,
Well, for organizers, for sure, but so that tells the design yeah, I heard that pretty cool. It is initially creating an engineering the dolphin to the creating.
Very good. Sorry. Yeah. Maybe I can. I just disabled. Should I? Why don't we just disable the waiting room? I'm going to disable the waiting room. That way, anyone comes in with this. I'm just looking for this security.
No, this way, yeah.
Otherwise, you keep admitting it. So, now, do you want me to share?
Yeah, I think we can start.
Whenever I can just share the. It should work, right?
That's the one.
Up to you when you want to start. I can finish in time.
No, I've got that everyone up at 5.
Okay, sure.
Everyone else is up for coffee.
Okay.
So, okay.
Oh, they're out.
So, thank you very much for being here. Welcome to this afternoon session. I'm very happy to introduce Siddhartha Sen. Siddhartha is a principal investigator in Microsoft Research Lab in New York. And his talk is going to describe how we can extract information about what constitutes human brain style in different games, focus on chess. We're very happy to have you here, and the floor is yours.
Okay, thanks a lot. Is this too loud? Maybe I can try to hold it. Okay, so I'm going to talk a little about how we can try to characterize what human playing style looks like. I want to do it more than just chess, but for now, most of the results we have are for chess. So I'll talk about that, but we'll see how we can extend it to other games as well. So chess and AI have a very long history, starting from 1948 when Turing created the first chess playing algorithm, and then Shannon described this minimax process of searching the game tree using chess as an example. And in 1967, John McCarthy called chess the Drosophila of AI. So what does he mean by that? I said the fruit fly of AI. The way biologists will study fruit fly is simple enough. Chess is an example of something that we can study because it's a very deep game, but it's simple in many ways. So fast forward to today, where in not today, but in recent times, where in 1997, Kasparov was defeated by Deep Blue, a massive computer that used alpha-beta search and a lot of databases. And eventually, a couple decades later, in 2017, we had AlphaZero, which used deep reinforcement learning, defeated Stockfish, which was the reigning heuristic-based chess AI project. So I argue that chess is a good model system to study when we're trying to look at how humans and AI interact. And there are a few reasons for this. One is that you have superhuman AI, and you've had that for a long time, since 2007. So you're already starting from a position of strength that we as humans cannot attain. Second is that humans, despite that, still play the game, especially during the pandemic. It's become very popular. VChess.org is an open source public database. It has over 3.5 billion games, diverse players from many different skill levels. So we have this kind of rich data set that's all public. It's also a relatively benign application domain, compared to things like self-driving cars and medical applications. This doesn't mean that there are no social or ethical implications of the work we're doing. We'll get to that a little later. But it's relatively benign compared to these other sense. By the way, I was kind of alarmed when I found out that all my games that I play are public. Anyone can see them, regardless of how embarrassing they are. I don't know how long this is going to last. It certainly doesn't feel great for me, but not only are they public, but the chess portals, they use your games to instruct and teach other people, how not to make mistakes by using real examples from their own mistakes. So it's kind of it's a bit more public than maybe it should be. Okay, so what does the interaction look like between SCI and humans? You have a given chess position and you turn on the engine, you say, okay, look at a certain depth in the game tree and tell me what I should do. And the engine gives you these options. So you see 3 rows that suggest different lines and ways that the game can play out. And so you have this very powerful engine that's something like 3,400 ELO rating. So this is an ELO rating system that's used in many games. Just for context, the world champion is maybe 2,800 something, right? We haven't cracked 2,900. So you have this massively powerful engine saying, here's what I would do. Whereas you have this human who's only rated 1,100 asking, well, what should I do? What's the right thing for me to do? Okay? So one person says, okay, well, I can take this engine and I can kind of dumb it down a bit, attenuate it. And in Stockfish, the way you do that is just limit the depth of the search. Maybe if I make a search less deep, it'll behave more like me. I'm an 1,100 rated player. But what happens with that is that you find that it does very strange things. For example, here bishop takes knight, the most natural thing to do is to take the piece back. But Stockfish 4 will do something like this. So what ends up happening is you have either a chess AI that just completely obliterates you, or that misunderstands you as a player. And our goal is to try to bridge that gap. So we're trying to see if we can use chess AI to instead understand how humans play, understand their strengths, weaknesses, what their individual playing styles look like. And then hopefully, when we have that kind of understanding, try to help them improve, and maybe even help chess teachers with their teaching efforts towards students. We can also think about how we might partner with humans in more collaborative play. In chess, it's not as common, although there are variants of chess where you have hand and brain, and you have 2 people playing side by side. So there are collaborative examples, but other games certainly a lot more opportunities to collaborate. And ultimately, it would be cool to use this understanding to create new and more enjoyable gaming experiences for people. So Maya is our first stab at that. The first, I would say, big step by now. Maybe last year I would say it was a little step, but it's a big step now, I think, big game. It is a neural network chess engine that tries to learn how humans play. And this came out in KDD 2020. I'm going to go through results of the papers, so I'll try to cite the papers where they come out. So what is the idea? Maya basically tries to predict what a human would do in a given position. So given a position here, Maya says, okay, let's see what the human move is. The human decided to move the bishop to g3 here. And Maya says, well, let me look at what the skill level that human is, and then we try to predict what the move is going to be. And if it manages to predict the move correctly, like in this case, they both predict g3, then that's success. So comparing Maya to Leela. So when I say Leela is just the open source version of AlphaZero. So we use Leela to build on that. So when you hear Leela, just think AlphaZero. When you compare Maya to Leela, in Leela, you were using self-play games, engine playing against itself, using deep reinforcement learning with the goal of trying to play the optimal moves. In Maya, we use human games, and we use the classification approach. We're basically using straight-up classification to try to predict human moves and approximate human-like play. Okay? So how do we do this? We took data from chess. As I mentioned, there are billions of games. Each game has the players, what moves they made, how long the moves took, the time between each move. Time is a very important thing in chess. We're not going to talk about that much today, but in chess, it really is all about time. If you have an hour, you play very differently than if you had like 1 minute. In fact, we filtered a lot of the games so that we didn't take data where there was only like 10 seconds left or 30 seconds left, because people just start playing bizarrely when they run out of time. Right? So what we did, we took games from a ELO range from 1100 to 1900. We made 9 buckets. And we said, we had a lot of games each bucket, like 12 million. And we said, let's try to train 9 different minds to try to mimic human play at these core skill levels, 1100, 12, 13. Okay? And what is ideal? So once we got the data that way, we then took Leela's architecture and we said, okay, this is the architecture used by AlphaZero and Leela to do DeepRL. We'll reuse this architecture, but adapt it and repurpose it to instead predict human moves. So now there's a policy head at the end, which doesn't tell you what the optimal move is, it tells you what move they think the human will make. And then there's a value head, which is on the bottom, which tells you what the likelihood of the human is for winning. Okay, so these are basically analogs of what a Leela-like architecture would do. We currently do not use tree search in prediction. So AlphaZero will take this neural network, see what it says, but also look through the tree search, do some tree search to look deeper into the tree before making a final decision. We don't currently do that. Others have tried to do that, and they have had more success. I still feel like this is an open area. And what I mean by that is I still feel like we don't have a good handle on how humans search the game tree. I think we're pretty good at predicting what move they're going to make, but how do they explore the game tree? Like, what branches do they consider, what do they prune? You know, I don't think we understand that very well just yet. So that's a nice direction for future work. Okay, so if we do our work correctly, ideally we would see performance that looks like this. The reason it looks like this is because for each evil rating we train for, the Maya should be able to predict with good accuracy the games played by people in that rating bucket. But it won't do a good job predicting people rated below it and people rated above it. That's at least what we were hoping to see. So it's basically fine-tuned to that, or honed in on that particular skill level. And we do get that kind of behavior. Okay, so these are all the Mayas, and you can see they have a peaking behavior. Our accuracy gets higher, the move matching accuracy gets higher as the evil gets stronger, but you still see that there's this kind of nice peaking behavior, which was, I think, quite surprising for us. Now, you can say, how do I compare that to what exists today? Well, you can say, well, let me see what would happen if I tried to use Lila or Stockfish. Remember, Lila is a deep RL, Stockfish is heuristics, although now it uses neural networks as well. What if I use them to try to match human play? Well, how do you do that? In Stockfish, the way you can kind of, I don't know if this is the best way to use these days, but the way you kind of dumb it down is to limit the depth of its search. And in Lila, because it uses deep RL, the way you can make it weaker is by limiting the amount of training. But what you'll see is that you can do these things, but it is not the same as learning how humans play. In other words, just because you can reduce the skill level of the engine so that it has the same evil rating, doesn't mean you've learned what moves a human to make, because you can achieve that rating using some very bizarre weirdo computer-like way. And you'll see that in the results, right? So all the Maya lines are peaking where they should, and they're above. And then Stockfish and Lila are all below. And it's not just that they have lower accuracy at predicting the moves, which is probably not that surprising, they weren't designed for that. But they don't really show you kind of peaking behavior or differentiation as much as you go through the rating levels. Okay, so Maya's accuracy is not just focused on certain kinds of moves like the opening. The opening tends to be a pretty predictable part of the chess game. People tend to play the same openings, right? So this plot shows you that whether you look at complex positions or simple positions, and here I've defined complex and simple based on what is the difference in win probability between the top two moves. If it's a very small difference, then maybe it's a complex position because it's very nuanced. But if it's a very big difference, then maybe there's an obvious move that's winning. And in both cases, of course, while we have better accuracy in simple positions, we also have pretty decent accuracy in complex positions. And our accuracy is better than what Lila is able to do. The same is true if you look at the type of move a human makes. They make a good move versus a bad move. And we also are able to predict both reasonably well. Of course, it's easier to predict the better moves. Okay. So you can try Maya yourself. I think maybe the internet's working here. So you can look at explore specific board positions. Like I said, I don't have to click this in case it's the screen won't be shared, right? Okay, so I can share that. You can look for Maya. There are places where you can explore different board positions. What's interesting about the widget website we have is you can see positions where people below a certain level make one move, and then people above a certain level tend to make another move. So you get an idea of these inflection points in skill level. Just kind of neat to think about. You can also play our bots on VChess. They're Maya 1, Maya 5, Maya 9. So as a result of learning how what moves humans make, we end up creating bots that are pretty human-like. So they become quite popular in VChess. Like within 5 or 6 months, I think our bots were the most played player of any player that exists in the database. That's not very fair to human players because our bots can play 24/7. But so you can't. It's not fair to compare it to human. But I will say it is a reasonable achievement because bots don't challenge other bots. Every game played by Maya is a human challenging Maya and choosing to play Maya. So the reception has been pretty good. People, kind kind of mischaracterize what we do a bit, but okay, this thing sucks on purpose. It's great. A lot of chess streamers that are famous have streamed videos of them playing against Maya and how they feel, whether it feels human-like or not. Each has announced in the blog post, our Maya 1 block has already crossed 1 million games. So it's quite heavily played. But more importantly for me is we would get feedback and emails every few days saying things like, I've been playing Engines for 15 years, this is the first time I play an engine that feels like a person. When it makes mistakes, they're natural mistakes, it's missing something in the midst of tricky tactics. So this obviously got us thinking, got us a little excited, and we thought, okay, how human-like is Maya? Can we prove or verify this? Can we do a Turing test? So we set up a Turing test. Can you tell which pair is Maya? So we have a beta version of this, we had a few betas. It was not as easy to set up as I thought. If you've ever read like Turing's original paper, you're sure it was like complicated. It's not that simple. It's not as simple as like bot or not, and then you pick. So the results were looking okay, but we haven't done a full-scale test yet. And one of the reasons why is that if you show enough games of a particular entity like Maya, regardless of whether it's human or not, people will start recognizing what Maya does. They'll learn Maya's quirks. And then they'll recognize, oh, that's Maya. But that doesn't mean that they distinguish between human versus AI. They just recognize Maya. I mean, Maya could have been another person. I could have played, I could have had fun playing like a billion games, and every game it's you versus some other human, and they might say, oh, I know who you are. But that doesn't mean they distinguish it. So we need more diversity of Maya models in order to make it a proper experiment. And so we set about trying to think about how can we create many more Mayas? Can we diversify our pool of Mayas? Right now we only have 9, right? We had 1 for each of the array. And so this led to this vision of, can you create a Maya for every person? What would that look like? And so we tried to do that. So starting from a base Maya model, we fine-tuned it using the players of the specific players' games, as long as they had enough games, like 5,000 or 10,000 games. And we reported these results actually. They came out recently in this year's KDE. So our fine-tuning methodology was not, I would say, novel. We just used a lot of existing ideas and tricks and maybe put them together in a somewhat interesting way. We initialized from the base Maya model. We didn't add noise. We tried that didn't work. We didn't freeze layers. And sometimes when you take a model and you want to adapt it to another setting, you freeze some layers. We didn't do that. That didn't seem to help. We did have to optimize a number of steps in the learning rate schedule and stuff that people usually do. And then what we do is we compare this, what I'm going to call a transfer Maya, because it's kind of like transfer learning. You're taking a bit model and transferring it to an individual. Compare that model to the nearest Maya, meaning the Maya that is closest in skill level, the 9 Mayas we have to your rating. And so you can see that if you compare the transfer Maya's accuracy to the nearest Maya accuracy, if you're above the 45 degree line, you're better. And if you have few games, like only 1,000 games to fine tune on, then you tend to be lower. But the moment you get past the 5,000 mark, the 10,000 mark, certainly the 20,000 mark in the number of games you have, if we fine tune your models, all our personalized models do better. Right? Like 3 or 4% at least better than the, or not at least on average, compared to the coarse Mayas that we had before. So this is positive news, right? This means that we are able to personalize the Mayas to specific people and get decent accuracy at predicting their moves. If you look at where the gains come, I can't say this very robustly, but I will say that I believe, based on evidence, we need to dissect this a little more, that our gains come from looking at the slight mistakes that people make. We're doing a better job of characterizing those. And I do think that actually the slight mistakes people make are a good differentiation in their style, as we'll see later on. Rather than the great moves you make or the horrible moves you make. It's this middle ground that's more distinguishing. So you can see the transfer Maya. If you look at moves in terms of moves that change your win probability, where on the left side these are moves that are perfect moves, on the right side these are moves that are bad because you lose. Your win probability changes dramatically. Right now on the slight mistake area where I've circled there, this fine-tuned Maya seems to do better. So now that we have these personalized models, we can ask this question: who played a particular game? We can try to get at what the differentiating style markers are for each player. So given a set of games, I show you 10 games, I show you 1 game. It's pretty hard, but it's who played this game?
That's the question we asked. And so our first approach to do this was kind of a bit brute force. We trained a personalized model for each player that we wanted to consider in our experiment, trained a personalized model for each of them. And then, given a set of games, we applied every one of those models to those games, and we just spit out the model that did the best, had the highest accuracy. And we say, oh, it must be that person. Okay? So I train a model for each one of us here, and we take some of our one person's games, and we try all our models against that game, and we see which one predicted the most moves accurately, and we report that model. Okay? Turns out that does pretty well. So if you look at just 10 games, we can get something like 86% accuracy. If you show me 30 games of a player, it goes up to 94, and at 100 games, it's almost 98%. Okay, so this means that I can uniquely identify you from a pool of players with 98% accuracy. Now, this pool wasn't very big because we had to train a model for each player. This was about 400 players that we just picked. We also look at later moves in the game. So we also stress our stylometry by saying, what if I can only look at move 10 onwards, or move 30 onwards? This is harder because now you lose the opening repertoire, which for some people is a unique style marker. And you really have to look at the middle game and the end game of chess, which is really where a lot of unique things happen. And it turns out there it's harder, but given enough games, you can still, start getting close to the 90s if you just have enough games to look at. So visually, if you look at what this looks like, if you put all the models in columns and all the players in rows, and you say, okay, which model matches or predicts the games of which player the best, you'll see this very dark line in the diagonal, which basically says that only that model that corresponds to the player is getting that high accuracy. And this is why you're getting these high numbers, like in the 90s. Now, training a personalized model for every player is quite costly if your only goal is to just identify who played the game. So there are more. So we thought of a more lightweight way of doing this, and that was to use an embedding. Okay? So what we can do is we can basically take a player's games and try to put them in some kind of embedded space using a transformer model. And then, once we've embedded players in the space, when a new player comes, we can say, okay, let's look at your games and try to place you in that embedded space. And then we can, once we place you there, now in the future, when we see any new games that we don't know who they are, and we can take those new games and try to find a point in the embedded space and say, oh, this is the closest person to those games. So it must be you. Okay. So in order to do this, we took a vision transformer, which was a pure transformer replacer for CNN and using vision tags, and we basically adapted it for our purposes. We had to change a few things. So this is what the architecture looks like. We have the moves on the left. They go into the CNN blocks, right? They eventually go into a transformer encoder. We had to encode the positions because all of these inputs go into the transformer at the same time. And so we wanted to encode the first loop, second loop, third loop. So we had a positional encoding that we used to try to pass that information on so that it's not lost. And eventually this stuff comes out and it produces a game vector. So this is for a particular game. Okay. So this is how we take a game, all the moves of the game, and put them in this embedded space. We trained this transformer model using something called generalized end-to-end loss, which was designed originally for speaker verification and audio, so it's kind of a similar task. In fact, a lot of these stylometry tasks originated in speech recognition, who's talking, whose handwriting is this. So this was something that NLP folks had looked at in the past. Right? And we're doing it newly here, but it's not something that people have tried to do in other domains. And so what this loss function basically does is it tries to minimize the cosine distance between your own games while maximizing your distance relative to other people's games. So once we have this trained game vector embedding, then whenever we want to get an idea of what is a player's vector, we just take all their games and look at the game vectors of all the games and then compute the centroid. And that represents a particular player. We're going to use that point in high-dimensional space to predict future games who played them by seeing who's closest to that centroid, or seeing which centroid is closest to the game's points.
Okay, so what do the results look like? So there's a lot of, the annoying thing about this work is that there's a lot of terms. It seems like it's a simple thing, but you have to define things like what's your universal player, what are the candidate players, what is a set. And so I will just define two terms here. One is the query set, and the other is the reference set. So the reference set says, here's a new player, here's 100 games, and hit them. Okay, now you have a handle on what that player is. Now, here's a new set of games. It's the query set. Tell me who played this. So we have a reference set for the players. I mean, if you know nothing about the players, we can't place them in the bed. But the point is you get some games about the players, and then you get a query set, which is also 100 games, and now you have to identify them. This is, the reason this is non-trivial, I mean, it's non-trivial in general. The reason it's more non-trivial than the previous thing I showed you is that I don't need to have seen this player in my training. I can train on all the other players. But when you want me to recognize a new player, just give me 100 games. And because I have this embedded understanding of this space of player styles, I can very quickly, with just 100 games, put it on. And then when you give me a query, I can match. So a lot of columns here, don't worry so much about it. Just focus on the fact that the candidate pool was 2,800 here, so more. Before we were only doing 400, so this is much more scalable. We did, we're able to do thousands of players, and we're able to get pretty good accuracy. So high 80s, high 90s. The difference between these two bands is what move we start from. Okay? So k equals 0 means starting from the first move, so you can see all the moves in the chess game. This includes the opening, right, which I said was a pretty useful style marker, makes it easy. And k equals 15 basically starts from the middle of the game, so it's much harder. But even with k equals 15, we're still able to get pretty decent accuracy. But I think that it's important that most of our results look at the later moves to really stress whether or not we're actually finding these unique style markers. Now, I don't need to apply that just by looking at the openings, I can distinguish people. There are not that many openings in the world. There's certainly more players in openings, so that's not enough. I'm just pointing out that it's a little easier, given a pool, a particular person, it narrows it down faster if you know what their opening is. Now, if you look at, so we did this, we varied k, and we tried to see, okay, because it's a transformer network, we have these attention heads, we can look at where the attention is coming. And if you start at the beginning, which is the blue line 0, or move 5, or move 10, move 15, you find that most of the attention is in the beginning of the game. So it is still the case that they're getting a lot of focus from the beginning of the game in trying to identify who these players and trying to decide where to embed them. And it kind of goes down as you go towards the end of the game. Okay, so I think we're doing okay. Maybe I'll just slow down a little bit, but I do have a few more things to talk about. I did want to go beyond this idea of psychology. So what I've shown you so far is that with chess we can create models that do a good job of predicting human moves at core skill levels. And then we're able to take those models and fine-tune them to individuals and get a pretty decent handle on how individuals move. And use this to do stylometry, meaning we're able to identify a person just looking at the games. What I found surprising to me is that the accuracy of the personalized models, it's decent, but it's not amazing. It's like high 50s, maybe low 60s. But that's good enough to distinguish people. Like, you don't need to really predict someone perfectly in order to identify them. Like, I just need to be able to predict just enough to know what's different. And that was kind of a little bit eye-opening for me. Like, if I'm trying to distinguish between two people, one person writes in French and another person writes in Greek, it's not so hard to distinguish them. I can create two pretty bad models, and one will do better than the other. Because one is trained on Greek and the other is trained on French. So, interestingly, you don't need perfect accuracy or very high accuracy to do stylometry. But what can we do with this stylometry? How can we kind of take this and use it for something useful and go beyond? So we've taken these ideas and tried to apply them to other games. That's one way of branching out, but with a purpose. We're looking at achieving a certain goal that we want with these games. I'll go back to our goals with chess. Like, my main passion with chess is trying to help people get better at it. I don't think there are many tools that really help you get better at it. I mean, unless you're really paying the money for working with a real coach. So we've looked at games that are simple stepping stones beyond chess. So Forza, for example, which is a racing game, it's got a limited set of controls, not too crazy. And there, one of the things they want to do is they have situations where you're using a phone and there's network lag. And when there's a lag, they want to fill in the controller actions to match your style, so that when the lag gets resolved, it looks like you're where you expect it to be. Bleeding Edge is a 4-on-4 brawler game. It's kind of not being updated much anymore, but it's still pretty popular. And one of the things that they're interested in doing is personalizing the training practice session when you're playing that game. And also, there's a lot of problems with how you create teams. Do you have enough people? Are they compatible? And how you match people. So team matching is a very big problem in Xbox, and I think it's very well studied. Having some idea or understanding of individual styles could potentially help you match teams better, or create more dynamic or interesting competition between teams, rather than a blowout, which is not really that fun for anyone, right? When one team completely dominates another. But zooming out and going beyond that, I mean, I hope that I can convince, I haven't yet, Xbox Next Club that there's a case to be made for creating a personalization architecture. And what I mean by that is creating a small personalized model for each player in each game that captures their style. It doesn't need to be a very deep or big model, but something small enough that we can use that to, for example, do specific practice for them when they want for training them to get better at the game, to do better matching in teams, as I mentioned. Xbox also has this co-pilot mode where if you need assistance, if you're a physical disability, there's a mode that assists you, and so the assistant can be done in a way that's tailored to the person. You can also imagine just creating other avatars that are much more human-like and populating your world with more interesting teams and more interesting players. So I think there's a lot of potential applications, and I think our results in chess and the results we're working with these two games and the game data right now, and looking at trying to do stylometry there. I feel like our results there, which are looking promising, will convince people that there is a case to be made for creating these personalized models of people for every game and every player. Okay, so going back to chess, or actually any of these games, really, one of my goals is to see, can I demonstrate human improvement? This is hard, and something that actually I really appreciate being in this conference, because I've seen a lot of different kinds of works and papers that look at the relationship between humans and games, their psychology, how they experience failure, how they progress, looking at so many different things that affect the human experience there that I think it's giving me a very different perspective than what I'm used to. So I'm learning a lot from listening to everyone's talks here. And I know people have done a lot of studies. I've seen a lot of studies presented in this conference. That's not something we've done with real humans yet. And I think that I find that honestly to be very hard. I think we can do it with our current system because Maya is pretty popular now, and so we have a user base. And we can probably convince a lot of people to do some kind of longitudinal study, but it's not going to be easy. So what we've done for the intern is to say, can I take the personalized Maya models I've created, which are human-like, right? Can I try to improve them with very small curriculum? How do I get them better? How do I go from this level of skill to this level of skill, starting with these human-like models? So that's what we did. We are in the process of it. I can't show you results just yet. I was hoping to show you this one plot, but I can give you a high-level idea of what the results look like. So we're starting with a Maya model, where we're going to personalize Maya model for a particular person, and we're saying, what is the simplest curriculum I can train it on that will improve the winning rate of that model? And you can consider many different kinds of curriculum. I find this to be quite fascinating. It's the first time I've had to sit and design a curriculum in this way. And I realized there are many different ways you can do this. For example, you can say, well, let me look at your mistakes of blunders as deemed by our super engines. I can try to correct those mistakes, right? That's one way of improving you. I can also just reinforce the moves that you did that were good, which is positive reinforcement versus negative. There are situations where the Maya model is deciding between several moves, like there's the model spit out the distribution of the moves. And sometimes there are a few moves that are equally weighted, and it picks one, but one of the other ones it didn't pick was better. So maybe I can help you when you're suffering from indecision, when you're suffering from indecision and you're not sure what to do, I can help you pick a better move. Maybe even more effective is if I focus on concepts where you're weak, right? What is a specific concept that you're not doing well? And for this, we need the advice of a real chess teacher. So we're working with Kasa, who's a friend and also someone who he's an IM. I really like working with him because he's IM who's really struggling to become a GM. He's working hard right now on it, so he's very active, training himself, and he constantly thinks about these kinds of differences between humans and AI, because the way that he prepares for tournaments is he finds situations where maybe the situation looks very drawn according to AI, but the way to keep it drawn is very difficult, and no human would be able to navigate it. It's very precarious. Right? So he's looking at a safety condition here, and this is why I think chess is a place where you can also have safety questions. So he spends a lot of time finding situations where it's very fragile, and if I navigate it this way, I'll put the opponent in a situation where if they don't make 5 perfect moves, they'll be lost. And most of the opponents can make 4 of those moves, and then they screw up on the 5th one, and this is how they get an advantage. So I like working with him because he does this a lot, and also he has very unorthodox teaching techniques, which I'm trying to basically incorporate into our AI tools. So he might look at a model and say, you know what, this player is not casting early enough. Or when they're up, like when you're up in trail, you should trade down. Do people understand why they're doing this with the chess? I don't know, maybe. So suppose you're up in a piece. If you trade all your pieces afterwards, then at the end of the day, you'll be up a piece, like 1 pawn or 2 pawns or a piece, and the opponent will have nothing. And then it's very easy to win the end game. So that's another concept that he often looks at some of our models and players and says, no, they're not doing that well enough. So we can create curricula like this and try to use those curricula to improve the models. You also have to ask what teacher you need to use when you try to improve the model, right? Because the curricula just tells you what positions you should focus on, but it doesn't tell you what advice you should do. So for example, suppose there's a particular position that's a mistake. I can say, oh, instead of this, you should do what the chess AI says, like stop coach. Or you should do what another Maya model says, like a stronger human-like model, more experienced than you. Or maybe what a human coach suggests, someone like Kasa. So you have to not only look at different curricula, you also have to look at teachers. So there's this, n times m kind of matrix of things that you can try to do. And our goal while doing this is to try to improve the winning rate, the performance of the model when we put it in tournaments. You can put that in tournaments and play them against each other, while trying to retain their individual style. So why do I need to retain their style? I feel like everyone knows that if you take a model and you bang it with enough data, you can make it like an engine, right? Our goal here is not to do that. Our goal here is to try to find a minimal curriculum that will improve it, while still keeping it like the same person, recognizable in terms of stylometry. Now, I don't know if that's really the right goal, because if I really train you to get better at something, maybe you become a different person. You're not exactly the same person as you were before, but I feel like you're not going to change that much. Or if I changed you that dramatically, then I don't think that this approach might work when I try to do it on a real human. Okay? So our initial results seem to show that Maya and human advice, if you take a curriculum and you override it with Maya and human suggestions, like stronger Maya and stronger human suggestions, it's much more effective than using an engine. And I think that's partly because we're working with human-like models. So if you take a human-like model and you start giving it engine advice, it doesn't really handle it very well. Okay? So I think that's kind of a nice result. What still remains a big question mark is how does this translate to how humans learn, how they improve? And we don't really have an answer to that yet. But our hope is that by studying this, studying these curriculum and these teachers, we'll come up with curricula that are likely to be good candidates for training humans to get better, to go from where they are to just that next level of expertise. Okay. That's all I wanted to say about our stylometry results and our plans for trying to help humans improve in games like chess, but also other games like the ones I showed you. And a lot of this is work in progress, so hopefully I'll be able to report more on it in future years. But I wanted to close by talking a little bit about the kinds of personalized models we create. When we create these personalized models, they really do a good job of matching the moves that specific humans would make. So you end up creating an AI that acts like a particular person. And I think that raises some interesting social and ethical questions. So consider a motivating example. I'm also using a different slide style because I want to speak for a different field of part of the talk. Because I think it is a different part of the talk that I want people to be some, hopefully get something out of it. There's a spectrum of mimicking human behavior that goes from not so creepy to pretty creepy, right? So deepfakes are one thing which can put people, can cause some unease in people. Alexa has this feature, and so does actually Microsoft has this custom voice feature where you can train on a little data. Let's say your grandmother who's passed away, and she can talk to you in Alexa's voice. Think about that. It's kind of weird. It's kind of, I find it would be bizarre to hear a relative of mine that's not even alive saying things that they would never have said. There are even apps that try to actually simulate the decisions that a person will make. Excuse me. So you can go and see what RGB would say about a particular question or case. Now, I don't know how they did that actually. I don't know if it's actually a very good model of a person, but you can see this progression, right? You start to go from like just caricatures that are static and not really real to something where you're trying to say, okay, what would this person have done? What decisions would they have made? And so we call these models mimetic models because they're trying to mimic what people would do. And we define them as, so a mimetic model is just a model that is trained on a specific individual, particular domain, and it's designed to predict and simulate the behavior of that individual in new situations. Okay? So it's targeted at a particular individual and trying to predict what their behavior would be in new situations. So a good example of this is precisely the personalized Maya models that we created, because they simulate what specific human players will do in the game of chess with pretty high accuracy, right? What actions they would take. And so one of the questions that came up, not just in our own heads, but when we were talking with the reviewers of the paper, what are the ethical concerns with the generation and widespread dissemination of models like this? Another reason this came up is because people started asking us to create models for them. Can you create a model for me? Can you create a model for that person? I'm like, what do you want to do with those models, right? We're wondering, we start worrying about it, like, okay, should we release these models of specific people that we created? We created models of like 400 or 500 people. Should these be released? No, that seems scary. So this is why we started thinking about the implications of this. So there have been many kinds of mimetic models, and babier versions that not really are mimetic. Things like language models that have been fine-tuned, chatbots, right? Autocomplete systems, image generating models that try to do things in the style of someone else. Examples like that, right? What we've identified in all these situations is that there seem to be 4 key players that matter. Right? There's the target. Target is the person you're trying to model. The creator is the person who created the model. The operator is the person who uses the model. And then the interactor is the person who interacts with the model. So for example, I might be the creator of a model for myself that I might hand over to a tournament to play a chess game, an online chess game, right? That will interact with other real players or other bots. So these 4 players, I think, are essential to define. They're minimal. I don't think you can remove or merge them. And so we identify different scenarios in which mimetic models might be used. We divide them into 2 categories. One is when they're used as a means to an end. So the mimetic model is used to prepare for future real interaction. Or the mimetic model might be used in an end as an end in itself, meaning that it's the main object of interaction. So as an example, consider the following. Suppose you're preparing for a competition, for a chess competition, and this is what really came to our minds when people were asking for personalized models of chess play. You could make a mimetic model of the opponent, and you could play against it to actually practice what it would feel like to play against them. You can ask even specific questions of our personal models, and what would you do in this particular situation? And you can prepare this way. And then you actually play them in real life tournament. Okay. So this raises some ethical concerns, right? It might undermine fair competition. I mean, you could argue that people today prepare, right? They watch their opponents' games. A tennis player watches videos of their opponents, right? But what if I could let you play against that tennis player, like a robot in real life? Like maybe that's a very different kind of training. And so does that undermine fair competition? It's a question that we should ask. Also, the player that you're using may not be aware, may not even consent. It certainly changes the nature of competition. Another example is preparing for an interview. Suppose you create a language model of an interviewer, the target in this case, and the creator practices with that to find out what works and what doesn't work. So that when you go into the interview, you actually say the right things, you don't offend them, you learn a little bit more about what they like. And then you keep doing this until you have a perfect interaction, and then you actually go and do your interview. So obvious ethical concerns arise there. You might have manipulated or exploited the target. You're able to circumvent things. The interaction no longer becomes as sincere as it might have been. At the same time, there might be some positive things. Maybe both you and the interviewer come better prepared for what each wants to hear, wants to talk about. And now examples of using a meta-model as an end in itself. One example is replacing work. So target replacement. So if an employer is there, an employee is sick or away, you might be able to use a mimetic model to actually to do part of the functionality that that employee was doing. So this has implications on the future of work. Now, likely it's going to be limited, things like short email responses or maybe short triaging, but it could develop to something that's much more meaningful. And I think one of the biggest ethical concerns that comes up here, in my view, is I'm devaluing the target. Like by creating these mimetic models of the target, I'm somehow affecting or devaluing reducing the value of the real person. And this creates kind of an interesting economics and an interesting market in how you value the real person versus the mimetic model that's trying to represent them. And this mimetic model may not even be that good at representing them, so you have to think about that as well. Another thing that's quite popular, I think, and common is creating counterfactuals. So you can create mimetic models of famous people and say, what would they have done? For example, try to write a new symphony by Beethoven, right? And argue that this is something that Beethoven would have written, or create artwork in a certain style, just like we've seen Dali. And of course, here you have concerns that you might affect the reputation of the person. They might be dead, they might not be alive, they might not be there to defend themselves or to give their consent. And you might actually end up exacerbating biases about history and changing what people know. And this has actually happened already because people make movies and they write books and they change, they twist the stories a little bit and then people start believing that that's the real truth. So the same kinds of harms can happen here, but I think it's going to be exacerbated because now you actually have a model that's trying to represent that person. So I'll end here. It's a little long enough. I just wanted to point out that in thinking about the ethical implications of mimetic models, there's certain dimensions that if you vary, I think it affects the severity of the ethical implications. One is how aware the target is of the mimetic model and how it's being used. Right? Is there consent? Are they aware of how it's being used? The other is fidelity. If you have a very bad model of a person, no one's going to really believe it and maybe attribute anything to that. But if your models start getting better and better, and they really behave and take decisions in whatever task or domain you're looking at, that seem like decisions and actions that the person would have made, then people will start paying attention to it, and the ethical implications become much more emphasized there. And finally, there is the relationship between these multiple parties that we've identified. Like how do the target, the creator, the operator, and the interactor interrelate with each other? One very telling example is when they're all the same person. So I might create models of myself to do work for me. Like I'm a coach, and I want to play practice games with my students, and I can say, okay, play against 20 of my mimetic models, and I'll do my own thing. I can use that same time to do an in-person lesson with someone. I can do my other work, I can sleep. Now, how do you value those interactions compared to the real interaction with me as a real person? So these kinds of interesting questions come up. Okay, I'll leave it at that. I wanted to just give you a taste of the kinds of ethical questions that are coming up as we create these accurate personalized models and as we hesitate to release them to the public. Because I think the ways that they're going to interact with humans and the humans that they're representing is going to be quite interesting in the coming years. Thanks.
So thank you very much. Are there any questions from the audience?
Go ahead. Sure. I think your hand is up first.
If I got it right, if I give you 100 of my 15, 98 out of 100 times you will be able to distinguish which of the two players I am in an unseen game.
So, right, so if you give me 100, so we're looking at across a bunch of players.
Can you please repeat the question for
the question was, if just making sure that
I haven't answered the question yet, but there was an intro.
Oh, okay. Do you want to say that?
I'll give you the answer. So you can let's say with very high accuracy distinguish which player is me from a pool of players, which makes me think am I that predictable as a chess player? And which takes me to the question, which is your model explainable at all? Like, is there some features that identify what is it that I do that makes me so identifiable?
Right. So the question is, if we have 98% accuracy with geometry, can I take 100 of your games and predict you with that kind of accuracy? And why am I so predictable? What am I doing that's making it so easy to predict my games, to identify me? So just to be clear, the 98% accuracy is an aggregate number. So we're looking across the players in the test set. We're saying 98% of the time we're able to get it right. So maybe with your games, we looked at 100 of them, but we analyzed them and we got it wrong. We said you're a person X, but you're actually not person X. But for 98 out of 100 people, we're able to get the right answer. I think people are I'm not saying people are not unique. I'm saying they are. But what I'm saying, I think, is that just in the course of playing 30 moves in a chess game and interacting with your opponent, and how you react to each move, there's enough richness there that you can use to identify you. And I think this holds for many games. I think even a racing game, you could say, okay, what's so identifying about a racing game? I think the way you turn in a racing game is another place where I think, distinguish you from thousands of other players. Just in the subtle ways, these are very fine-grained actions. Like imagine all the controller button actions coming every millisecond, right? Can I use that to somehow get an idea of how you're maneuvering in that particular game? So I think it is a little surprising, but now that I've seen us do in chess, I actually believe that I think we can do it in every other game. If it's rich enough. Like I don't think I can do it in tic-tac-toe. It's got to be a little rich.
So thinking about the best AI talk I have ever been, I'm not even going to be as awesome. I want to flip things a little bit because your talk reminded me of the story of this guy who, I think real in his GameCube was something 8 years after his father passed away, we used to play together. And there was this article where he just randomly discovered when he was playing one of those time tech, it was like a racing game or something like that. And you know how in those games you can play on the second loop there's like this ghost. That's kind of following your first loop. And then so if you go back to like again, you will play your previous laps. And he realized that was his dad, and he was so sort of surprised and so it was in tears, right? He would play that loop just kind of imagine it was like his dad, but he wouldn't finish the lap, he was finishing off to not override that same. So he knows his voice there. So with that preamble, I'm wondering if we flip that idea rather than can we make it into something that, it's like your mentor who's playing with you rather than against you, and it's the idea of bringing joy to the player rather than chasing the skill. Do you see there's
So the question had a very nice preamble about the story of some racing game, like a GameCube game where a person was able to go back into old game history and basically play a course but have a ghost of the previous play follow them, and that play had been their father's run on that game, and their father passed away. And so they felt very nostalgic and happy when they played it, but they never finished the level to avoid overwriting it. And I think you're asking, can we use this kind of ability in a more positive way, in a mentoring kind of way, or in a partnership? So I think a lot of the work we're trying to do on creating models that, I think there are a lot of good uses that can come up with. I think a lot of uses like that, and there's other media things. There was this person who created a bot, the chatbot of their deceased partner, and we just talked to them. It's very profound and thought-provoking. There's like a few lines where they're like, he's saying things to her, and she's like, why are you talking to me about this?
And he writes, it's because you died yesterday, or you died last week. And you know, I just have this, you read that conversation, it's just so striking and very emotional. I do think that there can be many positive uses. Being able to provide conversation, companionship, maybe even mentoring. And so an example with the example you gave, it's more like comfort and being able to experience that person that's no longer with us. But I also don't know enough about the psychology of that to know what the harms of that are. I think there are a lot of potential harms. And we've raised some of the ethical implications here of using these many models that they have. But we mainly focus on misuse of it. So I think you're totally right that our paper basically focuses on bad uses of it, but there are potentially good uses of it. We should think more about that.
I'm sure you guys thought about this, but there's definitely a little bit like you spoke at in the end with the deep phase. You could certainly revive some old masters, then you could play them, you know? Because we have all these documented games of even 300-year-old masters. Maybe that, maybe that possibly enough if you use some of your adaptation techniques. So anyway, did you consider bringing that
Yeah. So the question is like, can we take games that masters passed away in the past and create models of them and possibly recreate a tournament or matchups that never existed? I think that's definitely something that came up and people got excited about when we were talking about the results with one of the most famous chess coaches in alive today. He immediately lit up with this idea that he had, I want to see a tournament between this person and that person. And I think that if there is enough data, we could probably do something like that. I think for a lot of the older players that were like in the 40s, 50s, I think it would be harder to get enough data. But even if we were able to do that, then I have to worry about these ethical implications. Like suppose we misrepresent them when they lose, and I don't know, there's family members or descendants who are alive who are, you know, enraged because they would have never lost this game. So but I think you're right. It would be totally fascinating to do like a tournament between players that never happened. For example, there's a very famous match that didn't happen in chess, right? Because of you could say what would have happened if we did that match.
It would be a freak show. It would be funny.
And then somebody would make a lot of money from running it too, which is, you know, part of this whole thing. Yeah.
I mean, thank you.
Cool, right, exactly.
I'll be honest. Then no.
No. Oh, so sorry, go ahead. I thought you were going to tell me about the time. Okay.
Sorry, I thought you said second one over here.
Oh, no, please go ahead.
I think you were very good in crafting potential dangers and potential uses for your technology which are positive, again, like non-dehumanizing. You also highlighted, as I was mentioning, a lot of ethical problems that might arise from using it. One thing that I think you didn't touch upon, and I'm curious on hearing what your comments and thoughts are the idea of ownership. So you didn't, like, let's suppose it's obvious that it's your technology recording me playing on an Xbox. But I'm giving data to something that possibly I don't know is recording and getting my data. Obviously, then I can try to play against this thing and get possible benefits of this new player, whatever. But who is owning the data and the new player? So have you considered ownership as one of the ethical issues?
Yeah, I think we have thought about it. So it's a great question. The question was, we've looked at the potential harms of it and benefits of creating some many models. But one thing we didn't talk much about is the ownership of the data that might be used to go into creating such a model, and what are the implications of that? Who owns the data? What right do they have over the things you create? So I think I think ownership is something. I can't say that we have like the answers to what the right thing to do is, but I will say that in chess right now, I can't take anyone's data, train a magnetic model of it, and use it, right? If I have the technology. Our stuff is open source. We haven't released the models, but we've released the papers, and someone could do it. So it's kind of scary. I think what happens is the more powerful I think you can create with that data, the more people will demand ownership and control over that data, maybe even remuneration or more privacy controls over it. Chess is a particularly strange beast in that people have tried to claim ownership and IP over a chess game. hasn't worked in the past. I think primarily because there's two people involved, not just one.
And you're right in saying, like, we know who owns the data. For example, the data used a public domain.
Yeah.
But there was a signed up as public domain before we knew we could use them to
Yes, that's a good point. Yeah. So before we create any models of anyone, right now what we're trying to do is follow a process where we ask for their permission. So we wanted to, for example, create a model of a particular person and study them. So we went and asked their permission. And I think the reaction we get is like, it's kind of creepy, but okay, it ranges. And there might be people who want it, who ask for it. There might be people who are afraid, who don't want it. But I think you're right. You make a good point. That we created this ability using data that was public before it was known that this ability was possible. And maybe that's how all research might happen. And it's kind of scary. Like they might do something with it. Like,
shoot something that they didn't know they said yes to.
Yeah, right. Yeah.
So that's curious.
It's a good question. Yes. Yeah.
Sorry for one more question. So in the 3 or 4 examples you were giving about the different actors,
yes.
They all sounded like it's either harming or potentially harming the target. The target is never any out of this equation. So I'm wondering what if the target is also the person who's using the model. So therefore, they don't want to harm themselves, and they're going to naturally incentivized to do better. So for example, let's say I am playing some kind of RTS game like Star, but rather than playing 1 map, I'm playing 5 maps at once. So I'm training for AIs using my own games that's playing 4 different opponents, and let's say they're doing the same thing. And I can sort of change between them to, do this other map, but maybe the AI will take over another thing. Do you see examples of that creating new
characters? Totally. So the last example I gave was kind of like that. Let me repeat the question. The question was, a lot of the examples I've show the target is suffering from some ethical abuse in some form. And the question is, could the target be the person using the model and using it to a positive, to benefit themselves, such as playing multiple versions of themselves in a game or in other situations of learning or training. So the example I gave again, which I should have maybe given that example here, of me creating multiple versions of myself for a particular game or a particular purpose, like training students. That's one example where I could get value for myself, I think. You're right that if I wanted to, let's say, play a game and then I wanted to go to the bathroom or just go home because I'm tired or sleep and have still my avatar play it for me, I'd want it to be good. I had incentives for making a very high fidelity proxy of myself so that it does a good job, so people don't make fun of me. I don't know. Because I'm going to be affecting myself. So I think you're right that there could be many uses where the target themselves creates one or more models of themselves for a particular task and uses them. As we call, in our paper, we call this something, I forget what we call it, force multiplier is the word we use for it. Like, you create a force multiplier of yourself. Like, imagine if you had 100 of you. Think of all the things you could do. All the papers you could, that's not there yet. All the things you could. So I think, yeah, you're totally right that it is a cool way to kind of, as the technology comes up, you're able to create many models for those things, and it is a way to amplify or scale yourself up, if you will.
Can I ask a final question?
Okay.
Thanks. Actually, I was thinking about the same question with the first Barrett's question about explainability or interpretability or whatever. Let's say that you build a specific model of a grandmaster, Magnus Larsen, or someone else. Could you also build a high-level representation and say that this player uses this and that opening? Or in that situation, you would play move X instead of move Y, instead of predicting specific moves? Because I think that would be very useful in actually describing what constitutes that particular player and separating them from the others.
So the question is, can we actually use our models to put people in certain positions, in situations, and ask what they would do in those specific situations? And this also connected to the previous comment about explaining what our models are figuring out. So I kind of forgot to answer that question yet, but we haven't dissected the models enough. I think there's a lot of explainability research techniques that we should use, and we are trying to start doing that. I will say at a high level, I feel like most of the unique stat markers come from the slight mistake state. Mistakes and slight mistakes are technical terms in chess, in terms of how much you reduce your winning probability. And I think that's the sweet spot, as I kind of hinted at in the talk, where your uniqueness comes out, exactly what it is, and for a specific person, we haven't done that analysis yet. And to answer your question, yeah, you can take these models and put them in a specific situation, give them specific context, and say, what will you decide here? That's one of the powerful things about the models. I don't think you could do that with a real person. I suppose a real person, you say, hey, can you go to this situation and tell me what you would have done? They might not have the patience or time or even want to do it. But with these models, not only can you play a game with someone, you can play a game and then rewind it to a particular position, make a different move, and then ask the model, what would you do in this situation? You can't do that with a real person. I mean, unless that person's your friend, right? You can have a practice game with them, but you can't say, hey, can you go back to this move and then I'll do this instead, and then what would you do then? So I think you're right that it gives you, in some sense, a greater power than you might even have with the real interaction.
Also, minor question. Do you also take into account how much time it's going
Do we take into account how much time it's taken in any videos? Right now, we don't use time yet. But it's one of the things that people ask for, and we need to, I think we should. It's very interesting that happens with time. We're trying to keep it simple so you have enough time and see how you play, how you behave. When you start reducing time, then things get, interesting. In fact, when we first released the bots, they moved too quickly. People complained about that. Like, it's very human-like, but they move so fast. So we actually, if you play our bots now, there is some heuristic time delays. They're not like human learned. We haven't, they're enough to keep people like not complaining about it, but they're not, they haven't really learned how humans manage their time. But I think time is a very interesting dimension that we have not explored enough.
Just to follow up, where you didn't specify when it's pick of the yellow rating that you picked up for, is that for the unlimited yellow or for the 10-minute games or the 5-minute games?
So, in some of our datasets we use, let's say, as long as it's about 5 minutes, we use all the games there. We picked a yellow range that we could manage. It was not so easy to create grandmaster level human-like models. That was hard for us. I think we can do it now, but it's not as easy. I'm not exactly sure why. I feel like maybe grandmasters look a little bit more like robots than humans, and so maybe they're a little harder to distinguish or harder to create personalized models of that you can say, oh, that's this person, that's that person. But I think we just, I think now we can probably do it. In the early days, we were able to do things from 1100 to 2000, but above 2000, we weren't getting good results.
But so above 5 minutes?
Yeah, but we were using games like 5 minutes and above. We weren't going below 3 minutes. For most of the models I'm looking at here, it's I think 5 minutes and above. Okay, thank you.